Hi everyone, please ping me if I am audible. My screen is visible. Okay, thanks. So I got busy with some meetings, so it just got over. So that's why there was a delay of 15 minutes. Okay, so before we get started, let's talk about the agenda for the day. So we will take an example of RNN as we were discussing in the last class. So we will work through an RNN in real world. And after that, we will start CNN if time permits, or else we will start CNNs tomorrow. And we'll take an example for CNN tomorrow. Okay, so before we get started, a brief on what we have done so far is we have talked about the RNN models, and we know that RNN models are good when we talk about understanding the short-term or the long-term patterns in our data. Okay, so that means whenever you have a requirement where you want to predict something, but you need your model to have some memory, either a short-term memory or a long-term memory, so that it can remember what happened in the past, you will use RNN. मतलब RNN को यूज करने का मतलब ये नहीं है कि RNN should be used for natural language processing. ऐसा कि मतलब they understand language or English or some language. No, neural networks they don't understand even languages. तो ऐसा नहीं है कि RNN understands language. It's that RNN can hold these sequences, and whenever there is a model that can hold the sequences, that model is good for a language related problem. तो पहले आपको इतना क्लियर होना चाहिए कि हम मल्टीलेयर परसेप्ट्रॉन को क्यों नहीं यूज कर रहे हैं, क्योंकि उसकी कोई मेमोरी नहीं है, वो सिर्फ ट्रेन होता है और आपको आउटपुट दे देता है based on certain weights which get adjusted. But यहाँ पर not only those weights are important, but there are some memory components which we say as hidden states or memory cells. And in any language model, we need older history to be remembered in that fashion. So RNN in general is good, and they can remember the past history. But we talked about the problems with RNN, that they were only in one direction. So there are bidirectional RNNs, which is another thing, right? But again, there was a problem with RNN, which is a vanishing gradient descent problem, because there is this backpropagation. And to solve that, GRU came in picture, which contains two gates, or either LSTM we talked about, which contains three gates and two memory parameters. One is hidden state and one is memory. And LSTM can even remember longer memory patterns, but they are computationally complex. More parameters needs to be read or understood by the model as compared to GRU. Okay. So far, before we go ahead, any question, anyone, before we go ahead? Yeah, Gulzar. So when I am saying that there is a word like hello, how are you? Okay, let me type in this. Or say John started a textile factory. Now, if you talk about a unidirectional RNN, it will learn about, say, John. You want to understand who John is. It will say, okay, John is like a noun, a person, started maybe some action which John took. This is not as such needed. Then textile, it will say, okay, there is something about textile you are talking about, and it may know that, okay, John is associated with textile, but it don't know that this textile which you are talking about is actually textile as a cloth which John is wearing, or whether it's a factory actually, because your model is just going in one direction. So any decision taken at this level can only be based on the data which is जो आपने अभी तक देख लिया है. जो डेटा अभी आपने नहीं देखा, which is say, अगर आप इसको कहते हो टाइम t1, so this is टाइम t2, तो टाइम t1 पे आप टाइम t0 या उसके पहले की इंफॉर्मेशन आपको है, बट आपको इसकी इंफॉर्मेशन नहीं है. So you cannot really say that textile here is a factory. Your model can say, okay, textile may be a cloth because you're talking about a person. So model can say, okay, we are talking about some clothes here. But if it would have been a bidirectional model, your model will be learning in both directions, like this and this at the same time. And decision at any given point is actually a concatenation of these two. So decision at any point would be coming from the past data and the future data, concatenate to a point, and then it takes the decision, जो कि आपका y of t निकलता है मॉडल से, राइट? अगर ये न्यूरॉन्स हैं तो आपका एक y of t प्रिडिक्ट होता था, रिमेंबर? y of t which used to happen, ये आपका एक अलग मॉडल है, बट ये y of t जो आप एक्चुअल प्रिडिक्ट करते थे. तो bidirectional is all about this, Gulzar, where you are at any point, you are not only talking about the previous word or the pattern which happened at the previous time, you also look at what happened in the future. So you are learning using both present and future. Okay, that's what bidirectional is. And all of these models can be made bidirectional. Normally RNN, GRU, LSTM, they are all unidirectional, but you can have bidirectional GRU, bidirectional LSTM, or a bidirectional RNN that learns from the future words also. Or if it's a time series problem, so you can learn from the future also. Getting it, Gulzar? Gulzar, am I audible? So normally all of these models that we talk about are unidirectional, but when you talk about bidirectional, it's like this. If you look at this diagram, this is a simple RNN. If I talk about, not LSTM or GRU. So if you look at what's happening here is, in very simple terms, I'm telling you, is you have this particular see, this particular is your forward direction, where you are passing your input in the forward direction. Your model is learning as is normally learns in the forward direction, but there is another set of RNN cells, we don't say neurons, but RNN cells or nodes, which are learning in the backward direction. Like from the last word, they are going like, so it started from the last word. It started from the last word, and also what was predicted from here, and it keeps going. So at any given point, if you have to predict this value, which is your value at the time t0 or t1, t2, you will see that the output from both the neurons is actually concatenated, and it is ultimately getting summation and then the activation function. So if this is another neuron, there will be some summation that will happen. So some weight will be assigned for the past values and some will be assigned for the present values or the present words, and both of them will go in the model to tell you whatever the prediction is. So that's how your bidirectional models are. Or if you look at this also, it's just simply replacing those RNN cells with the LSTM layers. Okay, so at any point you have a forward node and a backward node. Your input will be going through both of these concatenated together before doing any prediction. There will be summation and then an activation function that runs on top of that. Instead of running activation function only on single value, we'll run it on both. But this model will be trained in the reverse direction because it's a backward layer. Okay, so but this backward layer, don't think this is backward propagation. This is backward layer, not backward propagation. Backward propagation happens to adjust the weights. So this is the backward layer, not backward propagation. Okay, so so far you guys are aware about these important models, but other than these, there are few more models that you guys can read about in the field of natural language processing, or in the field of even I would say RNNs. There are other models which are known as transformers or transformer you can say models. Okay, they have an attention model. Just for your knowledge, write it down maybe somewhere. Transfer models which have attention model. Attention as in memory. कभी भी आपको कुछ याद रखना है तो आपको attention चाहिए, right? जितनी ज्यादा attention होगी आप उस चीज को उतना ज्यादा याद रख सकते हो, तो उसी पॉइंट से ये attention model है. और attention model में दो main variants आते हैं, BERT and GPT. GPT आप में से कुछ लोगों ने शायद सुने हो, GPT 1, 2 and 3. किसी ने GPT सुने हैं? Anyone heard about GPT models in the field of OpenAI? Anyone heard about GPTs? Guys, yes or no? No problem, no problem. So BERTs and GPTs are the two variants of transformer models. So transformer models, just on a brief note, this is after LSTM, the advanced category is transformer models or attention models. These attention models or transformer models, they contain an encoder and a decoder. Two things they contain, an encoder and a decoder. You pass on your input to the encoders. Encoders generate some output. That output actually gets fed into the decoder. Definitely there is some operation that happens. मतलब ये आपका एनकोडर है, ये आपका डिकोडर है. आप अपना इनपुट एनकोडर में डालोगे, वहां से कुछ इनपुट निकलेगा. उस इनपुट के ऊपर हम कुछ ऑपरेशन करते हैं जिसको हम शिफ्ट ऑपरेशन कहते हैं. यू शिफ्ट द वैल्यूज, लाइक मान लो आप एक एक प्लेस से चीजें आगे पीछे शिफ्ट कर रहे हो. यू शिफ्ट द आउटपुट्स ऑफ एनकोडर्स. मान लो अगर इन जनरल आई एम टेलिंग यू, इफ यू गेट 1 2 3 एज आउटपुट and you shift it by one place, so it will become like say blank, then 1 and then 2. I'm telling you that. So you are shifting the data one level to the right. So you will get to understand these things in detail, the purpose of these things. But yeah, we do the shiftings and then we'll pass it to decoder, and decoder actually gives the output. Remember this, very very important. Transformer models or the attention models contains the encoders and decoders, and this is how they work. But what happens is, if we split this model and only take encoders, if you only take encoders and place them one after another, multiple encoders, on a model which only contains encoders, nothing else, no decoders, that's what the BERT is. Okay, getting it guys? That's what the BERT is. A BERT is No, Gulzar. I'm saying transformer models and attention model is one single term. Okay, don't differentiate them. But within these kind of models, you have encoders and decoders as two different things. Okay, just that. But now I am saying, other than transformer models, there are two more kind of models, the BERTs and the GPTs, right? So BERTs are those models which take multiple encoders one after another. And BERT का full form होता है bidirectional encoders representation. So that's what a BERT is. And if you only take decoders and one after another you put decoders, that what GPT is. Okay, which is like generative pre-trained model, GPT. So let me just show you, just to further feed in this information to you. When we talk about transformer models, if you look at this, okay, these are quite research side of the things. Just for your knowledge, if you look at, you pass in your inputs to this, and so this block, guys, this block is your encoder block, and this bigger block is actually your decoder block. Okay, so you have an encoder block and a decoder block. You pass on the inputs to the encoder. Encoder actually generates certain output to go into the decoder. Okay, there is some shifting, right shifting that happens. This all information goes into decoder, and then decoder further pass on this data to another say activation function, a linear activation function, and then a softmax activation function to generate the probabilities, output probabilities. Okay, आउटपुट प्रोबेबिलिटी मतलब आप प्रेडिक्ट करना चाहते हो कि आपने एक वर्ड लिखा हेलो, तो व्हाट विल बी द नेक्स्ट वर्ड. तो नेक्स्ट वर्ड कैन बी हाई और इट कैन बी से हाउ. आप कहते हो ना हेलो हाउ आर यू, तो इफ यू टाइप हेलो, it can, you want to do next word prediction, so it can be hi, it can be how, so it generates the probabilities whether the next word should be hi or how, और जिसकी भी probability ज्यादा होगी वो आपका नेक्स्ट वर्ड प्रिडिक्ट हो जाएगा. होता है ना, जब आप ईमेल टाइप करते हो, आप एक वर्ड लिखते हो, नेक्स्ट वर्ड प्रिडिक्ट करना शुरू कर देता है. सो टुडे वी आर गोइंग टू यूज दैट. So today the model we are going to implement is that only, next word prediction. You are typing something, but you will get suggestions for the next word. You type SMSs, this happens. You type emails, this happens, right? So this is what they give. They all give the output probabilities. Okay, because you are predicting next word. You are not predicting a regression value, a continuous value. Okay, so this is about the transformer models or the attention models, okay, which are quite state of the art models, quite good, I would say. So this is one of the another example which is doing machine translation from okay. Okay, so this is, we are doing a machine translation. We are passing on certain words, and then it goes into the encoders. It goes into the encoders, and then it goes into the decoders, and then decoders generates like I'm a student. So that's what the conversion is happening here. Okay, so in general that's the transformer models, but then there are BERTs and GPTs. So BERT, if you look at, I'll just pick some simple one. So BERT, if you see, it's nothing but bidirectional encoder representations from transformers. Okay, and not to go into much detail right now, there is GPTs. So GPT is generative pre-trained models. And why GPT is very famous? Because of this thing. Getting a call, 1 second. Okay, sorry guys, there was a call, official call. Yeah. So what I'm saying is, uh, this GPT is a set of models which are being used uh, by OpenAI, which is another company, uh, and they have been giving the environment as free for anyone to run their models, their complex requirements you can run on their platform and get the output. But now they have recently launched GPT-3, like version 3, and from GPT-3 it will be paid. Up till GPT-2, it was free, their environment, the OpenAI environment. But you guys can read more about it. I think this OpenAI is associated with Elon Musk again, the guy who is behind Tesla. So this is their environment. So they work on the OpenAI, and here you can use GPT based models, and they allow you some free environments to run those models. Okay, so you can read about this OpenAI more later. Okay, so they are working in the field of artificial intelligence, and there is one more term, artificial general intelligence. Read about it. Difference between AI versus AGI. So you can read AI. I'm pinging AI versus AGI. This is very important discussions in today's world. Artificial intelligence is no more needed. We need artificial general intelligence. What it is, just read about it. And Vipul, no, BERT and GPT can be used independent of each other. You don't need both of them. Okay. BERTs are separate and GPT are separate. They are enhanced models, but the idea behind them was transformers only. Okay. Okay. So this is a never-ending field, I would say. So let's restrict ourselves to this only. Okay. So there are further enhanced models that we cannot go into, but yeah, you can definitely read these many transformer or attention models, BERTs and the GPTs. GPTs version 1, 2, 3. OpenAI is investing too much in GPT. Okay. So with that, let's start this thing. Yeah. So now let's start the model implementation. And when we have to do the model implementation, so what we are going to do is next word prediction. That is what we are going to implement. But if you look at the top, I think you can see this jar here, right? Hourglass, this hourglass. So my models are still running, guys. I started it 1 hour back, but still they are running. So I'll walk you through what's happening here. Let me just check what's happening here. Okay. So this is my model, which is still running. I think, okay, it's completed. Huh? This model, yeah, this model just completed. Okay, this model just completed, but the another one is still running. So we'll talk about that in a while. Meanwhile, I'm pinging you this. Just import these libraries and see if all of you are able to. If anything fails, like pickle or all, please pip install it. Give me 1 minute. I'll put this on charger. Meanwhile, you please import this. Create a notebook on next word prediction. So we will type a word and then the next word will be automatically predicted by the model. I'll be back in 1 minute. Okay, guys. So please ping me if you are able to import these libraries, or is it failing for anyone? Perfect, perfect, perfect. Okay. So now you guys are aware about the problem statement that we are going to solve is, say if I am typing even a sentence like John started a textile, it will automatically tell me the next word is factory. Okay. Because model have learned that particular thing. Okay. So now what we need to do, guys, we need to first of all understand that this is a natural language problem. Okay, so we need data to train our model. So what I have done, I have taken some data as in few sentences or paragraphs uh, that I have used. You can use any domain data. The point is कि जो मॉडल आप ट्रेन कर रहे हो, आप जिस डेटा पे ट्रेन कर रहे हो, उसी डोमेन से रिलेटेड आप उससे क्वेश्चन कर सकते हो मॉडल से. मतलब आपने अगर उसे हेल्थ केयर के किसी डेटा के ऊपर ट्रेन किया, तो जो नेक्स्ट वर्ड वो प्रेडिक्ट करेगा वो उस नॉलेज पे करेगा जो आपने पास ऑन किया. बट अगर आप उसे कुछ ही और कंटेक्स्ट में बात करना शुरू कर दोगे तो मॉडल विल नॉट परफॉर्म गुड. Okay, so this is quite important for you to remember this. So here I have taken some general data which is about a person, Grigor. Okay, this is a sort of a story. You can take your own data from any novel or anything and train it. Okay, so we are talking about a person who is like traveling, opening a factory, doing something, playing, going out. Okay, so that entire chapter is there about that particular person. So now, whenever you have data, you have to first do the cleaning of the data. Like if you talk about structured data, you do feature engineering. So here also we will do feature engineering. और ये वही होगी जो हमने नाइव बायस वाले प्रॉब्लम में किया था. अगर आपको याद हो, नाइव बायस वाले प्रॉब्लम में हमने टोकनाइजेशन, स्टैमिंग, लेमेटाइजेशन किया था, राइट. तो जब भी आपको नेचुरल लैंग्वेज डेटा दिया गया है तो स्टेप्स वही सिमिलर ही हैं जो हमें रिपीट करनी है. तो सबसे पहले मैं क्या कर रहा हूँ, वो जो भी आपकी नॉवेल है या बुक है उसको आप रीड कर लोगे, राइट. उसको पहले एक ओपन कर लोगे फाइल को रीड मोड में, और देन उसको लाइन बाय लाइन एक एरे में स्टोर कर दोगे. सो दिस इज लाइक एन एरे वेयर ईच लाइन, मतलब each entry of that array will be a line or a sentence. So we have opened it and we have ran a for loop on it. So what you guys should do in parallel with me, I'm pinging you at least this much of the content. Please create a file, just copy this much content, create a file with any name and read it. So ये जो मैंने कंटेंट अभी आपको पिंग किया, उस फाइल का कुछ नाम रख दो, ABC or whatever. Okay, and then run this code. Okay, do it in parallel with me. फाइल का नाम यहाँ मैंने मेटामॉर्फोसिस रखा हुआ है, आप कुछ भी रख सकते हो. दिस इज अ फाइल. वी विल क्लीन दिस फाइल. Whatever extension you want, .csv, .txt, keep it .txt for the time being. मतलब जब भी आपको फाइल रीड करनी होती है तो बहुत सारे तरीके हैं. आप पांडा से भी रीड कर सकते हो, नमपाई से भी रीड कर सकते हो, बट ये जो तरीका है ये बहुत ही पुराना तरीका है फाइल्स को रीड करने का. यू कैन यूज दिस ऑल्सो, but you can use pandas also. Let me check what we did last time. So अगर आप वो नाइव बायस वाला ओपन करेंगे तो आप देख भी सकते हैं what we did the last time. So guys, if you are able to read and print the first and the last line of the document that you have loaded, just tell me. So last time we used pandas. See, we used pandas to read it, and pandas gave what, like it gave a data frame instead of like an array, but you can convert a data frame into an array also, or an array into a data frame also, which is like another thing. Okay, good. So now we are able to do this much. Okay, so now you are given some data. You are able to first load it row by row. Now we have to clean it row by row. When I say clean, you know, we have to first remove stop words or the punctuations or like dots and all. So if you look here, our data contains some new line characters, some single quotes, maybe some stop, okay, uh, dots, commas and all. So we have to remove it before we pass it to a language model. So we are cleaning this. So this is the thing that we are doing. We are replacing it. Okay, we are replacing each new line with blank, each carriage return. This carriage return is like an enter. If you press enter, this is known as carriage return. And the other Unicode characters, these are some special Unicode characters that are there in my data. So I want to remove all of them. So what you can do, just follow along with me. I'm pinging you. This thing, if you guys already know, it's fine. I'll tell you later. There we are just joining this data together, these lines together. Before running this operation, we are just making it as a single data. But this is what the main part is. You are replacing the bad words. Just do this. And even in the last time when we did it in a different way. Okay, even last time we converted into lowercase also. So हम वहाँ पे भी उसको lower case में convert कर सकते हैं. Okay, and then we did some other replace functions to replace it. Okay, so far we are not replacing bad words, but Anam, good point. When we talk about bad words, we actually don't replace them, we remove them. Okay, so we don't replace bad words, we remove them. Like any slang or any such words that we don't want our model to actually learn about, we remove them. It may be some other kind of content which is not needed. Okay. So different ways of cleaning, different functions to clean the data, but they are all doing the same thing. So what I did was all the lines I first combined together and then I cleaned it, cleaned the data. Now, once I cleaned it, as in I first removed the new line characters, the carriage returns or the enters, and some other Unicode characters. This is what I got. But if you still look at, I haven't removed punctuations. अभी यहाँ पर क्या किया है मैंने, सिर्फ न्यू लाइन कैरेक्टर्स और कैरेज रिटर्न को रिमूव किया है. But now I need to remove punctuations like comma, full stop, all of those. So for punctuation, you don't need to really specify punctuation word. You can use this string class. A string class already know what are all the available punctuations are. 1 second. So if you look at, there is this string class or string package which know about all the punctuation words, string dot punctuation, and then you are just creating an object. This is just to create an object, and then what you are doing here is, this was my original data, which is the original data. I'm saying translate. I'm using a translate function, and I'm passing a translator. Translator actually have the logic what you need to do. So the translator logic is, I want to do the transformation as in to remove these punctuations. Okay, and how to remove them? I am saying remove these punctuations with the spaces. Okay, it's just removing the punctuations with spaces. I'm just doing that for all the words which are available in the document. So this is the translator. Let me ping it to you. Just do this. There are other ways of doing this again. You can remove punctuations in other ways also, but yeah, this is one of the way. You can use the string class which already contain all the possible punctuations, and then you are just translating the data and see print this data, the first 500 words. So because this is next word prediction, एक तरह से each word is like, अगर आप सोचें तो this is your x and this is your y, means using this you want to predict that next word is this. Understand it. When I pass one, next word should be morning. When I pass one morning, next word should be when. When I pass Grigor, next word should be Samsa. So that means this is your x, this is your y. Then this will become x, this will become y. समझ रहे हो मैं क्या कह रहा हूं? यहाँ जो सारे वर्ड्स हैं वो आपका एक पहला वर्ड x है, दूसरा वर्ड आपका y हो गया, फिर ये वर्ड x हो गया, ये वर्ड y हो गया. Getting it? Nishtha, yes, tell me. What's not found in directory? Which file? No, what I didn't get it. What you are doing is this the file that you are trying to run? Did you save it with this name or some other name? It's meta, M-A-M-E. You put, I think, M-A, in case you are trying to use the same code that I ping. Please check that or ping me the code that you are written, that's throwing the error. It's done? Okay, perfect. What was the problem, Nishtha?
So my Jupyter file is not reading it, even when it's in the same directory and even if it is having the same name.
Same directory, same name. Okay, but you are able to read anyway somehow?
No, sir, it's completely showing an error.
Okay, so when we will take break, I'll give you the screen sharing, right? You can tell me. Or you may restart the kernel and check it again. Or create another file, put some other name.
Sir, I've restarted it, but it's not working.
Maybe some problem with some setting, something. I have to check it. But let me check if others are able to do it. If not, then I'll tell. Is it working fine? Like, guys, are you able to follow along till this cleaning? Okay. So what you do? So what you can do here, I'll tell you, Nishtha. In the meanwhile, what you do? This lines is there, right? Yeah. So Nishtha, what I'm saying you to do is you just assign this. You just do it. I'm pinging you 1 second. So you can do this instead of reading the file, just to follow along and not to lose the pace. You create your own array, because ultimately this lines is an array of lines for me, right? So it's fine, Karan. Instead of, you can skip this and you can directly continue from this point, as in just skip all this, directly create that object which I have pinged you, like this. Okay, but I'm just avoiding it in my case. Okay, now once you have converted everything, say in the smaller case or the upper case, which is one thing. You remove the punctuations, you remove the enters and the new lines. Yes, Rahul, absolutely the same thing that that's what we are doing. When you're typing text in the mobiles, it tells you the next word, or when you're writing email, Gmails and all, right? It tells you the next word, right? Based on the past emails you have written. So what Google do is, for you, it customizes it. It also see कि आपने पास्ट में क्या किस तरह के ईमेल भेजे हैं. तो कई बार आप देखते हो, आप जैसे ही हेलो लिखते हो, वो नाम भी बता देता है पर्सन का कि क्या आप ये भेजना चाहते हो. For that it definitely looks at कि आप किसको मेल भेज रहे हो. But there are a lot of such concepts कि आपका टू में कौन है, सीसी में कौन है. कई बार आप थैंक्स लिखते हो तो वो थैंक्स के साथ रिगार्ड्स भी सजेस्ट कर देता है. Okay. So far we have cleaned the data, but now comes the most important part, tokenization. So understand it. What's happening here? You have the data, as in you have the words, like everything will be the words for you. When you remove all these punctuations and everything, you will get the words, plain words. And then when we tokenize this, we get the words like him is like one word, waved is another, about is another. So you will get ultimately an array of words, right? Array of words. Now this is what you actually need to pass into your model to train it. Okay. This is what you need to pass, because that's what I told you. First word will go, say, time t0 into the RNN cell. Second word will go, right? Then another word will go, right? Like this, the words will keep going in. And here the prediction will be the next word. Here the prediction will be the next word. So if I'm saying him, the next word that will be predicted should be waved. Okay, waved. And when it's pass waved, the next word should be what? Guys, can anyone tell me? If I'm passing waved, what should be here? Next word? Very good, Vipul. Yeah, Karan. Good, good. Just wanted to check if you are following along. So that means if this is a part of the sentence that I'm passing into the model, when I pass him, मैं मॉडल को सब कुछ पास करूंगा, क्योंकि मैं तो ट्रेन कर ही रहा हूं ना. मैं तो ट्रेन कर रहा हूं, तो मैं सब कुछ पास करूंगा. बट जब मैं कोई वो चीज पास कर रहा हूं, मेरे मॉडल को क्या प्रेडिक्ट करना चाहिए? अगर उसने वेव्ड प्रेडिक्ट कर दिया तो ठीक है, बट वो शुरू में तो नहीं करेगा. शुरू में वो कुछ और वर्ड प्रेडिक्ट करेगा. तो मुझे फिर एरर निकालनी पड़ेगी कि डिफरेंस बिटवीन द एक्चुअल नेक्स्ट वर्ड एंड द प्रेडिक्टेड नेक्स्ट वर्ड. वो एरर निकलेगी पहले, और उसके बेस पे फिर ग्रेडियंट डिसेंट होगा, बैक प्रोपगेशन होगा. विपुल, आई डिडंट गेट इट. टू डायमेंशनल एरे कहां पर दिखी है आपको? मतलब अभी तो वन डायमेंशनल एरे ही है, सिर्फ वर्ड्स का. बिकॉज टू डायमेंशनल एरे पे मैं आऊंगा डेफिनेटली, बट अभी आप टू डायमेंशनल एरे किस चीज को बोल रहे हो यहाँ पे? यू गेट इट विपुल? मतलब अभी तो ये वन डायमेंशनल एरे है ना, बट इसको अभी मैं टू डायमेंशनल में कन्वर्ट करूंगा. एक्चुअली मैंने आपको कल बोला था, राइट? कल मतलब प्रीवियस क्लास में कि वी नेवर पास वर्ड्स, वी कन्वर्टेड इनटू वेक्टर्स. वी विल सी दैट, right? But yes, Vipul, okay, I got it. So what you are saying is it's like x and y, where x is input, y is output. So in that way, if you are saying it's two dimensional, yes, you will pass a input, get output, input, output, input, output. That's what. Okay, so that means him will be your x and waved will be your y. Then waved will be your x, about will be your y. Is it clear, Vipul? परफेक्ट. बट ये तो हो गई टू डायमेंशनल डेटा की बात, लेकिन इनपुट तो वन डायमेंशनल है. तो दिस इटसेल्फ इज इनपुट विच इज वन डायमेंशनल एरे, एंड दिस इज आउटपुट विच इज अनदर वन डायमेंशनल एरे. Yes, Gulzar, very good. First word is the independent variable and next is the dependent variable. Absolutely. बिकॉज मैं बार बार आपको क्या बताने की कोशिश कर रहा हूं, RNN को इंग्लिश, जर्मन, फ्रेंच समझ नहीं आती है. इट द गुड थिंग इज इट हैव मेमोरी. अदरवाइज वो भी एक मल्टीलेयर परसेप्ट्रॉन की तरह ही है, बट उसमें मेमोरी है सीक्वेंसेस को याद रखने की. तो लेकिन अब याद हमें रखवाना है उसे, राइट? तो वो हम पे डिपेंड करता है. तो मैं करंट मतलब पास्ट प्रेजेंट के फॉर्म में अपना डेटा कन्वर्ट करूंगा. ओके, सो आई एम डूइंग दैट. तो अल्टीमेटली मुझे डेटा इस फॉर्म में कन्वर्ट करना है. बिफोर आई पास दिस डेटा टू द मॉडल, मुझे उसे इस फॉर्म में कन्वर्ट करना है. ओके ओके. Another important thing is when we pass the words to the model, we don't pass word actually, we pass a number. Means we will encode like you do one hot encoding, right? Here also we do an encoding and give a number to each word, but it's not exactly one hot encoding. It is something known as embedding. We will talk about it, embedding. Yeah. So what I'm saying is ultimately this particular thing will be converted into this. So I'm not doing one hot encoding, I'm not doing binary convergence Nishtha, I'm not doing 0101. I am saying for each word I will assign it a unique number, because my models are mathematical, so they cannot understand a word, because you have to do mathematical computations, 10h, sigmoid, right? Everything use what? X and gives you Y. So how will you work that 10h function on him or sigmoid function on him, or how will you do summations on him? Getting it? So what you will do, you will convert each word with a number, a unique number, so that it's like dictionary. In dictionary, each word is having a particular order, right? कि पहला वर्ड, दूसरा वर्ड, तीसरा वर्ड. उस तरह से आप मान लो कि आपके हर एक वर्ड को एक यूनिक नंबर मिलेगा, वो सेम नंबर दूसरे किसी वर्ड को नहीं मिलेगा. लेकिन इससे फायदा क्या होगा, जो हम आगे देखेंगे, कि अगर मैं कहता हूं हेलो राहुल, what should I say, we visit Agra and then we like Agra, for example. अब इसको अगर आप नंबर्स में कन्वर्ट करें तो आप इसको 1 दे सकते हो, फिर अगले को आप मान लो 33 दे दिया विजिट को, आगरा को कोई नंबर है 44, आई एम जस्ट सेइंग यू. बट नाउ वी को फिर से क्या मिलेगा? 1. लाइट को क्या मिला? मान लो 22 कुछ नंबर मिला है. आगरा के लिए फिर से क्या है? 44, राइट? तो अगर आप देखें तो हर एक वर्ड को एक यूनिक नंबर यहां मिला है, लेकिन इस पर्टिकुलर स्ट्रिंग को एक तरह से मैं देखा जाऊं तो ये मॉडल में पास करना मेरे लिए एक तो बेटर है. ठीक है, just to pass this information. So this is what I will do. So my model will do the tokenization, where after tokenization, first tokenization will happen, right? Tokenization will do this. Tokenization will do this, right? Guide, understand? Huh? A sentence will be tokenized means each word is a array, part of an array. Each word is part of an array. Once I tokenize it, then I put numbers to each word, unique word as in. Okay. So it's like text to sequences. So we are converting the text into sequences or some numbers. So that's what Karan I told you, right? Your model will only learn those words which are in the file that you're passing. Your model will not understand anything about other things. So ये हमारी original file है, right? इसमें जो भी वर्ड्स हैं मॉडल उनको समझ लेगा, बट उनके अलावा के वर्ड्स को नहीं समझेगा. And that's what the problem with NLP. You need huge amount of data to train it, because in real world it may not capture all the scenarios, right? This data, it may not be a representation of the real world, and that's where not all next word prediction models are accurate. It all depends upon amount of the data that you feed in. And that's why this model, when I trained, it took 1 hour for me to train this model, only on this much data. Only on this much data. This is not considerable data, but it took too much time, more than 1 hour. And we will see this. See the number of the parameter that I had to train in each layer. It's like 4 million, 8 million, 1 million, almost how much? 2 million. Yeah, 2 million. So you're seeing the number of parameters I'm training. So obviously it will take more than an hour. We will come to this embedding and all these things. But yeah, so many parameters my model is going to be trained on. तो डेटा बढ़ेगा तो ये चीजें भी बढ़ेंगी. ओके करण, गेटिंग इट? एंड गुलजार, मतलब नया वर्ड अगर आपको ट्रेन करना है तो वही है कि आपको मॉडल को रीट्रेन करना पड़ेगा उस नए डेटा के साथ, तो वो फिर से उतना ही टाइम आपका वापस लगेगा सारा. ओके, देयर इज अनदर फीचर. हाँ बोलो बोलो.
क्या एक एक वर्ड को ऐड करने के लिए टाइम कंज्यूमिंग होगा ज्यादा?
ऐसा नहीं होता ना, एक एक वर्ड आपको पूरे डेटा पे ट्रेन करना पड़ता है. अब मान लो कि ये पूरा डेटा था, अब आप इसमें एक नया पैराग्राफ ऐड कर दो, तो आप सिर्फ उस एक पैराग्राफ पे थोड़े ट्रेन करोगे, मतलब एक तरह से सारे डेटा पे दोबारा ट्रेन करना पड़ेगा मॉडल, क्योंकि सारे वेट्स फिर से एडजस्ट होंगे. तो ये
मतलब
एक प्रॉब्लम है.
मतलब जब भी कुछ नया ऐड करेंगे हर बार दोबारा से ट्रेन करना होगा?
एब्सोल्युटली.
ठीक है.
Okay, but if you want to avoid that, there is another field of machine learning. We are not going to talk about it. Transfer learning. Those of you who are interested, they can read about it. As I tell you, this is a very deep field. Deep learning is a very deep field. Transfer learning is, Gulzar, something where you can avoid retraining everything. You can only train on something which is new, leverage what was old. That kind of things you can do. There is something known as transfer learning. You can read about that also. Okay. But there is one more thing you can do, Gulzar, is if you can store the weights somewhere, the older weights somewhere, and while training again, if you can leverage the older weights, you really don't need to retrain on the entire data. You can only train on the new data, and the weights will be adjusted. There is another thing where you can store the weights somewhere in a separate model and then retrain that model, which is also possible. Okay, but you can explore those things also. वेट मतलब जितने भी पैरामीटर्स अल्टीमेटली आपके लर्न हुए हैं वो वेट्स हैं. एक मॉडल वेट ही होता है. अगर आप उन वेट्स को कहीं सेव कर लो और अगली बार ट्रेनिंग में मॉडल को बोल सको कि पुराने वेट्स को आपको यूज करना है, तो वो आप कर सकते हो. और उसको हम एक चीज कहते हैं वार्म स्टेट. सो देयर इज समथिंग नोन एज वार्म स्टेट वेयर older knowledge that you have gained from the past learning can be passed on to the new learning. Okay, warm state. If you put it to true, your model will actually not start from zero. Okay, when you are training a model and you keep warm state at true, मतलब warm मतलब गर्म रहेगा, वो गर्म रहेगा मतलब पुरानी वेट्स की नॉलेज को रखेगा और उसके हिसाब से नए डेटा पे वेट्स को एडजस्ट करना शुरू करेगा, रादर देन बिल्कुल जीरो से वेट्स को स्टार्ट करे. जीरो मतलब रैंडम स्टार्ट करे. यस गुलजार, यस. ओके, अच्छा एक चीज बहुत ही इंपॉर्टेंट है जो आप लोगों को पता होनी चाहिए कि वेट्स जो होते हैं इनिशियली कुछ वेट तो मॉडल्स को मिलता ही है, राइट? अगर मान लो ये 3 न्यूरॉन्स हैं, या तीन न्यूरॉन्स नहीं कहूंगा मैं, आरएनएन की बात कर रहा हूं, तो मैं इनको क्या कहूंगा, 3 टाइम स्टेप्स हैं ये आपके. तो यहाँ पर एक वेट होगा इसका, एक वेट होगा इसका, एक होगा वेट इसका. कैन एनीवन टेल मी कि शुरुआत में वेट्स की वैल्यू क्या होगी जब मैं पहली बार मॉडल को स्टार्ट करूंगा? बाद में तो बैक प्रोपोगेशन इसको एडजस्ट करेगा, बट स्टार्टिंग में मेरे वेट्स की वैल्यूज क्या होंगी? विल इट बी, let me give you 4 options, will all be zeros, like w1 w2 w3 all be zeros. Second is all will be some random value but same, like 4 4 4. Third option is they all will be different values but again random. And fifth is which Vipul says, because there are 3 weights, so 100 divided by 3, 33.33, 33.33, like that. If there are 4, so like 100 divided by 4. Can anyone think about it and tell me? Should be in the same proportion, not sure about the values, different and random. So Harshita's answer is absolutely the right one, which is they will all be different and random. Yeah, correct. So it's like they will be all different and random. They cannot be same. They cannot be equal, because if they are equal, then your neurons will somehow will be learning the same things. All the nodes are learning the same things. If the weights are same, so whether it's MLP, whether it's these kinds of models, we make sure, or the model internally makes sure the weights are different and random, and then backpropagation adjusts them to their accurate values. Okay, so far we know now that we do the tokenization and then we do sequencing, like text to sequence, as in we assign numbers to each of the words. So let's wait. I hope you guys have done till punctuation. Yeah, Gulzar, means consider this scenario. For example, a simple MLP, a 3-layer hidden layer and an output layer. What you are doing? You are passing, say, 2 features, right? And from here also you are passing these connections. Now I am saying, if this node is getting both x1 x2, अगर ये weights, मान लो ये weight 0 है और ये 1 है, बट यहाँ पर भी ये weight मान लो 0 है और ये 1 है, फॉर एग्जाम्पल. तो अगर ये दोनों weights सेम हो गए, मतलब एज इन ये 0 0 और ये 1 1, अगर मैं ये भी लूं, तो ये मॉडल तो ये दोनों न्यूरॉन्स तो सेम ही चीज को लर्न कर रहे हैं, या ये भी दोनों मान लो 1 1 है, they are learning the same things, right? बिकॉज इनपुट वैल्यूज भी सेम मिल रही हैं इस न्यूरॉन को भी और इस न्यूरॉन को भी, ऊपर से मैंने ये वेट्स भी सेम कर दिए, तो वो तो गलत है. गेटिंग इट गुलजार? क्योंकि इस न्यूरॉन को इस न्यूरॉन को और इस न्यूरॉन को इनपुट फीचर की वैल्यूज तो सेम ही मिल रही है, बस फर्क क्या हो रहा है इन तीनों में कि इनके वेट्स अलग है. अगर मैं वो वेट भी सबके सेम कर दूं तो ये 3 न्यूरॉन्स एक तरह से डेटा पे ओवरफिट होने की तरफ चले जाएंगे और बायस हो जाएंगे और मेरे प्रेडिक्शंस वोंट बी एक्यूरेट. Okay, so one second. So guys, I think you have done till this place. What's happening after that? We have this new data, which is this. This is the punctuation that we did. You can directly work on this. What's happening here? The data here. So guys, please do this tokenization. You can comment this thing, okay? Comment this thing. This thing is particularly, you can ignore. This thing is of no use. You can ignore this. I'll tell you what this is, but as of now, this is of no use. Because I told you, right, we can store our models in the pickle files. There is a concept of pickle files. So it's just dumping this tokenizer in a pickle file so that this can be used in another model if needed in future. But we really don't need to worry about it. So normally in the last session, we use NLTK. NLTK is, I'll tell you, NLTK is Natural Language Toolkit. It's Natural Language Toolkit. You can directly use the word tokenize there, which is another way. So we did this, right? In the last class, we word tokenized everything. But here we not only doing word tokenization, but we are also assigning a unique word to each of them. So along with tokenization, we are assigning a sequence, okay? A sequence to each of the word. So I'm just drawing parallels with what we did last and what we are doing now. So it's like text to sequence. So Aditi, this is to fetch the first row, the first part of the array. The second will be the words. So if you want to see that, what you can always do this. Let me tell you. What happened? So what it's doing, Aditi, is it's just converting two-dimensional into one-dimensional, nothing else. Just converting two-dimensional output into one-dimensional output. So if you look at the two-dimensional was this, but what I was saying is there a way to see the words also? But here it's not showing you the words which are associated with this, but we can also do that. We can also see the words which are associated with each of these numbers. But currently the purpose of doing this is to convert two-dimensional into one-dimensional. The output of this particular function is two-dimensional. So if you look above, this is what was happening. So it was a two-dimensional output. And because we want to further use this ahead, we only want one-dimensional data, not two-dimensional representation of the data. So that's what is being done here. Okay, Aditi, it's just converting two-dimensional output into one-dimensional output. And if you want to look at, you can definitely look at the data. So this is what your data is, which is being tokenized, and then some numbers are assigned to it. Okay, and the same word is not assigned the same number. It, as in, the same word if occurring again is not assigned a new number. The older number is used, which is already assigned to. So if Agra is coming again and again, new numbers will not be assigned to it. The older number will be leveraged, which this particular function will take care for you. Okay. So now we have the data. So what we are now just checking is total how many unique words we have. So it's like 2600. You can check for you also, like, let me see. I cannot use this. I can check length. Let me check if length is possible. So these are the total words. I'll check and let you know why this is. It may be something, but yeah. When I look here in the tokenization, even let me run it again. The total unique words that I have in this entire system is 2617. I'll check and let you know what's the difference between this and that. Let me check meanwhile, 1 second. I converted into sequences. Sequences is there. Okay, that I'll tell you later. You can note it down for the time being. Yeah. So this is my vocabulary size. Yeah, Aditi, we should convert it to uppercase or lowercase. We can, but it depends on the model that we are going to implement. Okay. So models may internally also handle it, but yes, we should do it. Okay. But it depends on further processing that we are going to do. So you can convert it into lowercase, all of these into lowercase, or later we can do that. So now what we have is, so Nishtha, what tokenization is doing is, even if you look in the last time, tokenization का काम सिर्फ इतना होता है कि हर एक वर्ड को एक एरे का पार्ट बना देना. ओके, हर एक वर्ड को एक एरे का पार्ट बनाना. लेकिन टोकनाइजेशन करने के बाद नेक्स्ट स्टेप जो आती है वो है कि इस हर एक वर्ड को एक नंबर असाइन करना. ओके, in the naive Bayes problem, in the naive Bayes problem we did something different. In the naive Bayes problem we have to identify whether this is ham or spam. So we converted each of these into features, right? So each word was my feature. And if this is one sentence, the value was 0, 1, 0, 1, like that. That's what we did last time, because we have to do a supervised machine learning problem. Guys, getting it? Last time याद रखना पड़ेगा आपको कि अभी क्या डिफरेंसेस आएंगे. लास्ट टाइम भी हमने नेचुरल लैंग्वेज प्रोसेसिंग ही की थी, लेकिन वहां हमने टोकनाइजेशन के बाद स्टेमिंग, लेमेटाइजेशन ये सब तो कर दिया, बट जो फाइनल हमारे पास वर्ड्स बचे थे, हर वर्ड हमारा एक फीचर था. यहां पर भी हर वर्ड एक फीचर होगा, बट उसको हम सिस्टम में पास कैसे करेंगे? पहले हमने हर एक वर्ड को या 0 या 1 की फॉर्म में पास किया था. वो वर्ड उस पर्टिकुलर ईमेल में प्रेजेंट है या नहीं, क्योंकि हमें हर एक ईमेल को इंडिपेंडेंटली एनालाइज करना था. यहां ऐसा नहीं है. यहां आपके लिए ये वर्ड अगर मल्टीपल सेंटेंसेस में भी आ रहा है, आपके लिए वो सेंटेंस लेवल का डिफरेंशिएशन यहां खत्म हो जाएगा. गेटिंग इट? एक तरह से ये सारा का सारा आपके लिए एक पैराग्राफ है, और इस पूरे पैराग्राफ में ये वर्ड जितनी भी बार आ रहा है या इसके साथ कौन कौन से वर्ड्स आ रहे हैं, मुझे वो पता होना चाहिए, रादर देन कि ये वर्ड किस किस सेंटेंस में आ रहा है। मुझे ये पता होना चाहिए कि ये वर्ड जब भी आ रहा है, इसके साथ नेक्स्ट वर्ड या प्रीवियस वर्ड कौन सा है। गाइस, इज इट गेटिंग क्लियर टू यू? एनएलपी के अलग अलग कॉन्सेप्ट्स हैं। पहले हम जब हर एक ईमेल को बताना था कि वो हैम है या स्पैम है, तो हमारे लिए इस तरह का रिप्रेजेंटेशन था। अब ऐसा नहीं है। अब अगर मैं कहता हूं, इसको मैंने एक नंबर दिया वर्ड को 10, मान लो हाय एंड हेलो, और हेलो को दिया 11, तो मेरा एक जो इनपुट बनेगा वो बनेगा 10 एंड 11। फिर बाद में भी कहीं पे अगर ये हाय आया और लिखा है हाय राहुल, राहुल को एक नंबर मिला है 22, तो मेरा जो नया ट्रेनिंग रिकॉर्ड होगा वो होगा 10 एंड 22। नाउ आई एम प्रिपेयरिंग माई ट्रेनिंग डेटा। फिर दोबारा से कहीं पे आया हाय और आया हाय से व्हाट आर यू डूइंग, सो हाय के साथ व्हाट, सो देन व्हाट को एक नंबर मिला है मान लो 40, तो नेक्स्ट ट्रेनिंग रिकॉर्ड विल बी 10 and 40. You are getting it, guys? This is my training data. But earlier this was the training data because I was doing naive Bayes supervised learning. Now this is my training data because I just need to know for every given word what is the next word. So this word can come multiple times, so there will be some weight that will be assigned, that if this particular combination comes most of the time, so when you type hello, you type hi, model will still give probabilities for all these three words, but the maximum probability will be say for this word. So the next word that will be predicted to you will be what instead of Rahul or hi. Guys, getting this? It's still NLP, but the concept, the way you're preparing the data is changing. Okay. So one second. So last time when we were doing naive Bayes, we just converted into some sparse matrix, and then we just pass on that data as X and Y and did it, where each feature was the word. Here it's a bit different. Not this. Okay. So Aditi, I think Aditi, Nishtha, you guys are clear now. We converted this two-dimensional to one-dimensional. That's why we took this. Then I'll tell you, but this is what is important, that the tokenization that happened, that tokenization had how many words, like how many unique indexes. So you calculated that. This tokenizer was a model which got trained on my data, and it know that these many are the unique words. So word index tells you like the last index value, and the last index value was 266, and now it starts from 0, so total will be 2617. So the last word, it will be this, the last word in that tokenizer string will be 2616 index, but because it starts from 0, so we have added 1 to it. So total vocabulary size is this much. So at the 0th position, 17 is the number, and this 17 will correspond to some word actually. At 2616, we have 1922, which is actually a word, means the index for a word, but I can map it back to the actual word, which I don't know, but there will be some actual word for this. But this is what the tokenizer did. Tokenizer gave some numbers to the words. Now these are those numbers, and these are the indexes of those numbers. Remember, these are the indexes, but these are the numbers, and these are the actual words which we can look back. So ultimately now we know that our entire data, the data that we have trained a tokenizer to convert these words into numbers. Wait, are you guys able to run up till this? Please do this. Run this also. Just create a vocabulary size, because this is important. This will go as the number of neurons in your layer. We'll pass it later, but just do it. Your vocabulary size can be smaller because the data you use may be lesser. Okay guys, let me know if you are able to do up till this place. So now what we need to do is this, which I have been telling you for long, is we have to convert that data in this particular form. As in, if initially after doing that tokenization and all, my arrays will be like 73, 53. Okay, let me type in like this. So आपके पास आया होगा 17, उसके बाद 53, उसके बाद 293, उसके बाद 2, मतलब ये वर्ड्स हैं। 18वें नंबर पे कोई, मतलब 18वां कोई नंबर हुआ होगा, कोई वर्ड हो रहा होगा, लेकिन अब मुझे इसको पेयर्स में कन्वर्ट करना है। तो दिस विल बी वन पेयर, सी 17 एंड 53. This will be another pair, see 53 and 293. This will be another pair, see 293 and 2, then 2 and 18, like this. ये हमारा पैटर्न बन रहा है. So let me copy the first 10 words. I'm taking the first 10 words from that tokenized data, and I'm just putting it here for your knowledge. And if you guys try to map this with this, it will make sense, right? 17 and 53 का एक पेयर, 53 93 का एक पेयर, इस तरह से पेयर बना दिया हमने. Is it clear guys? अब वो पेयर बनाने के लिए हमने कुछ प्रोग्रामिंग की है यहाँ पे. Okay, which is nothing related to NLP. We did some basic programming just to pair the words. Like we kept adding them into a two-dimensional array. So you can go through this. This is a simple programming that we have done. So please do this. You have this sequence which is available to you, and from that sequence we are finally doing this entire work. Let me just check something. Okay, you do this and see your data. Meanwhile, I'll tell you. Yeah, guys, call that as is and see what happens. If you're able to split that, please let me know. Or if you face any error, let me know. So I was just taking this data in Excel to count total number of words that I have. So I think it's something 19,692. So I was just doing that. But this still contains bad words like maybe commas and all. So I may have to remove those. But those of you who want to just do the count of records, they can also do this. Like Excel is one of the good ways to do that. But in general, there are like multiple ways of doing this. Okay, let me just check if any questions are there. Done. This might help to understand better. Okay, guys, please ping me if more of you are able to do this. Okay, so perfect. So Aditi, there is no name to this process. This process is just known as like preparing your data. It's just the data preparation. So after tokenization and sequencing, we did two things, tokenization and sequencing. now we are just preparing our data in the form of trained data and test data. So you can say that you are preparing your trained data and test data now. So far you didn't have the trained data and test data, so you can say it as that. If you want to put a label here, it's like splitting the train and test data or preparing it. So now once I have the data in this particular form, what we have to do now is we have to split it into two particular vectors, I would say. Take them out separately, which is like train and test. Sorry, not train and test. If I said it's like features and target. Okay, Aditi, it's like you have to split your data in features and targets. It's not train and test split, it's features and targets. This is feature and this is your target. So I'm now, since I have the data in this particular form, now what I need to do, I need to split it further, take X separately and Y separately. So this data will become one array and this data will become another array. So it's like 0th indexes I will take and 1th indexes I will take. So that's what I'm doing. I'm taking the 0th indexes, okay, as my X, and 1th indexes like these as my Y. Keep traversing over this entire two-dimensional array and I'll get my X and Y. Simple. So I'm giving you this code. This is going to take time actually, NLP definitely. But yeah, I want all of you to follow along. So now what I'm doing is, from the initial data, I just paired it. From the paired data, I just separated it. Okay, because doing देखो इस फॉर्म से पहले हम इस फॉर्म में लाए हैं और इस फॉर्म से अब हम इसे इस फॉर्म में लाएंगे. Like X separately and Y separately. X as a separate array and Y as a separate array. Okay, guys. So if you look at, so ultimately this is pointing to this and this is pointing to this. For this as X, this is your Y. For this as X, this is your Y. And that's even logically correct because of this kind of sequencing. Okay, guys. So what we are doing now is we are just looking at the data, a few top records. That's it, nothing else. This is just to see if my data is looking good. So this is my data and this is how it looks like. Now what I am doing here is I am doing one word to one word modeling, as in for one word I want to predict another word. But if I want, I can create a model which contains say two words, use two words, a combination of two words. होता है ना कई बार जब दो वर्ड्स, ये दो वर्ड्स अगर आ रहे हैं तो तीसरा वर्ड कौन सा हो, तो वो भी एक अप्रोच होती है. या मैं कहूं कि तीन वर्ड्स, ये तीन वर्ड्स हमेशा जब साथ आ रहे हैं तो अगला वर्ड कौन सा है. इसको हम कहते हैं एनग्राम्स. सो लेट्स सी एनग्राम्स. What do we mean by that? Okay. So now before we proceed ahead, now do any one of you know what is n-grams? Anyone? Guys, what are n-grams in natural language? In n-grams, any idea? Even if you look at the screen, if it's making any sense before I tell. Can anyone understand what this means? There are bigrams, trigrams. So what that means is, see, taken into, yes. So what we are doing is we are building a unigram model. Unigram model as in, for every word, what is the next word? For every word, what is the next word? For every word, what is the next word? If it would have been bigram, so for these two words, like bigram means two words, and then मतलब बायग्राम का कॉन्सेप्ट प्रिडिक्शन से कोई लेना देना नहीं है. बायग्राम का सिर्फ इतना मतलब है कि दो दो वर्ड्स का ग्रुप. अब मैं बायग्राम को यूज करके मॉडल बना रहा हूं, वो एक अलग बात है. ट्राइग्राम को यूज करके बना रहा हूं, वो एक अलग बात है. कि मतलब अगर आप मिनिमम कोई 3 वर्ड टाइप करोगे तभी मैं आपको चौथा वर्ड प्रिडिक्ट करूंगा, तो वो मेरा क्या हो जाएगा? ट्राइग्राम बेस्ड मॉडल हो जाएगा. तो अब ये भी आता है जब आप एज अ डेटा साइंटिस्ट सोचोगे कि भाई आप क्या बनाना क्या चाह रहे हो, 1 ग्राम, 2 ग्राम, 3 ग्राम. तो कई बार क्या होता है, जब आप पहला वर्ड टाइप करते हो, आपने देखा होगा, तो कुछ वर्ड प्रिडिक्ट होता है. लेकिन जैसे आप दूसरा वर्ड टाइप करते हो तो थर्ड वर्ड में चेंज. Okay, you type third word, the fourth word may change, right? So that's because the model is trained for unigrams, bigrams, trigrams, like that. So you have to pass the combination of three words to predict the fourth word. Making sense? Yeah, Gulzar. Means don't use the word comma. Just say unigram means it's just one word, or it's like group of 2 words or group of 3 words. We really don't need to talk about commas as such. But yeah, you are right. So what we are building is a unigram model. Yeah, Gulzar. Okay. But if it would have been a diagram model, yeah.
सर एक बार डायग्राम फिर से डिस्प्ले एक बार.
Yeah.
सर जैसे इसमें यूनिग्राम और बायग्राम, इसमें इज या इज को कोई एक ही सेंटेंस में वो, जैसे बायग्राम में इज और ट्राइग्राम में इज को ये रिपीट करने का पर्पस क्या है इसमें?
नहीं, अरे आप सही कह रहे हो. वो एक्चुअली ना ओवरलैपिंग विंडोज हैं, वो सही से दिख नहीं रही. ये पूरी एक ओवरलैपिंग विंडो है और ये वाली पूरी एक ओवरलैपिंग विंडो है. गेटिंग इट? वो इजे को अलग से दिखाना नहीं चाह रहा, वो एक्चुअली यूनियन हो गया है, इंटरसेक्शन, सॉरी, वो इंटरसेक्शन आ गया है, इसलिए ऐसा लग रहा है. ओके गुलजार, मतलब यहाँ देखो, है ना, दिस इज अ और इज अ सेंटेंस, ये दो अलग है. वो एक्चुअली यूनियन होने की वजह से वो ओवरलैप है. ठीक है. ओके. सो लेट्स गो बैक टू दिस थिंग. तो अगर मुझे यहाँ पे यूनिग्राम की जगह ट्राइग्राम मॉडल बनाना होता या कुछ बनाना होता, मैं सिर्फ बता रहा हूँ, वो भी हम कर सकते हैं, कुछ रॉकेट साइंस नहीं है. बस उसमें क्या हो जाता, आपका हर एक वर्ड इस तरह से हो जाता. अंडरस्टैंड इट? एवरी वर्ड विल बी, मतलब every, instead of every single number you would have a internal array, and that array will be like this. तो हमें डेटा प्रिपेयर करने में थोड़ा और दिमाग लगाना होगा उस केस में, है वो भी सेम ही. 293 के बाद क्या है? 2. तो 2, तो एक तरह से ये आपका इनपुट सेट ऐसा बनेगा. instead of this input, so this is your input, right? You will get this kind of a input. Getting it, guys? ट्राइग्राम में क्या होगा? I'll ping you, please convert it into trigram and ping me back. अगर यहीं पे मैं 3 वर्ड बेस्ड लैंग्वेज मॉडल बनाता, प्रिडिक्शन मॉडल, नेक्स्ट वर्ड प्रिडिक्शन, तो इसका क्या होता है? मुझे पिंग बैक करो जो मैंने एरे भेजी है उसको चेंज करके, फिर हम एक ब्रेक लेंगे, बट मुझे पिंग करो पहले. ट्राइग्राम में कैसा दिखेगा वो? Okay. Yeah, Gomini, you are correct. Gulzar and Pragisha, you are missing the outer brackets. Yeah, Rahul, correct. Correct. So tell me that if you move from unigram to trigram for the same data, is your training data size increasing, decreasing, or remaining same? Listen again. For the same given input, instead of building a unigram model, if you build a bigram or a trigram model, is your input space increasing, decreasing, or remains the same? Okay. Yeah, Nishtha, you are right. Anyone else? Okay. Okay, perfect. So Gulzar, what I'm saying is, we are preparing our input data for the model, right? But we are using currently what? Unigram. But if you move to a bigram or a trigram, is your total number of input records increase or decrease or remains the same? Okay, so they decrease, right? Because in general, these three are three different records. But if you make a trigram, it's just one single record. Getting it, Gulzar? If you make it a 5 gram, this is like one single record. Currently, these are 5 different records. So your input space shrinks. Your feature space does not shrink. Feature space is still same, but the input space shrinks. Okay. Feature space is still 2 features, as in, or I would say one feature and one target. Your feature space is not shrinking. Your input space is shrinking. So guys, let's take a break. We'll connect at 6:10 or 6:15. Okay, let's connect at 6:15. Then we will see how we will transform the target in this form, and then we are just at the model. Yes, Gulzar, you're right. So we will talk about this embedding layer and we will talk about this. Okay, let's connect at 6:15. Yeah, guys, we will start now. Gulzar, no, class was not resumed. We are starting. Okay. So far, what we have now is, yeah. Okay. So far what we have done is we have split our data in two parts, right? Two separate parts, like X and Y. But now, as I told you, model does not understand words. A model does not even understand numbers. What model needs is vector. So we have converted words into numbers, but now this numbers needs to be converted into vectors, and that's what the model will learn. So what we can do is we can convert our input into a vector and output also into a vector. So we will do that. Okay, so we will convert input also into a vector and output also into a vector space from a simple array. But for the time being, let's consider that we have converted input into a vector space and output also in a vector space. But what after that? Okay, I'll come back to that. But the input into a vector space and output into a vector space. And now we have to create the model because that was the last step. And now it's ready for the model. So when we are creating a model, again, from Keras, we have the sequential model. And in the sequential model, we are adding the layers. So what we are doing, we are adding an embedding layer. So we'll talk about it. And after that, we are adding an LSTM layer with 100 cells or nodes. Another LSTM layer with, 1000 layers and 1000, 1000 nodes. Okay, 1000 nodes. So it's layer 1 with 1000 nodes, layer 2 with 1000 nodes. Then there is a dense layer with 1000 nodes, or you can say neurons here. Here you can say neurons, and here also you can say it's a dense layer, but with how many neurons, which I'll tell you. But now we first need to understand this before we go back and talk about that vector space. This embedding layer is another spatial layer. What it do is, it's like you have an input layer, right? Normally you talk about an input layer. Here, the embedding layer is going to play the role of input layer, but in a different way. What we mean by that is, normally we have an input layer and then we have our hidden layers, right? But the embedding layer is actually a part of the hidden layer only. So means it's nothing but a hidden layer. So if I'm saying embedding layer, that's actually a hidden layer. That's a hidden layer. But it's having a direct relation with the input layer. So normally embedding layer is just to replace the input layer. However, input layer को हम layer में count नहीं करते, embedding layer को हम layer में count करते हैं. और मैंने आपको बताया था कि अगर कोई layer रियली में layer है, मतलब वहां कुछ computation होना चाहिए, कुछ processing. So that we will understand that what is that processing which embedding layer is doing. Okay. So first of all, remember that this embedding is a special kind of a layer, which is actually a layer because it do some computation or processing, and then it passes its data to the LSTM layer or whichever is the next layer. Okay. Then you will see that this LSTM layer does not have this value set. So return sequences is true here but not here. Why? Because if you have a LSTM layer which is sending data to the LSTM layer, right, you need to set this as true. What that means is, because LSTM layers understand sequence, right? LSTM layers, they understand sequence because that's what they learn. So if you are passing any data to LSTM layer, so that should be a sequence. So the first input layer, sorry, the first LSTM layer needs to have a sequence, and that sequence will be generated by the embedding layer. Okay, so the work of the embedding layer is to generate a sequence for the LSTM layer. And this LSTM layer, whatever output it is giving, it is not necessary that it is in sequence. बट क्योंकि हमारी ये लेयर भी LSTM है तो हमें वो सीक्वेंस प्रिजर्व करना पड़ेगा, तो हमने बोला कि भैया आप सीक्वेंस प्रिजर्व करो. बट ये जो लेयर है LSTM लेयर, इसके बाद अगली जो लेयर है वो है डेंस लेयर. तो डेंस लेयर को सीक्वेंस से कोई लेना देना नहीं है. वी रियली डोंट नीड टू वरी अबाउट इट. सो यहां हमने सीक्वेंस को ट्रू नहीं किया. तो याद रखो, जब भी एक RNN लेयर से नेक्स्ट RNN लेयर पे डेटा जाएगा तो सीक्वेंस ट्रू रखना है हमें. मतलब वो लेयर जो भी प्रिडिक्ट कर रही है या डेटा जनरेट कर रही है वो उसका टाइम सीक्वेंस रिटेन होना चाहिए. तो ये सो डेंस लेयर इज नेवर सीक्वेंस, राइट? बिकॉज अगर सारी लेयर डेंस हो तो MLP हो गया, राइट? और MLP कैन नॉट लर्न सीक्वेंस. सो डेंस लेयर कैन नॉट लर्न अ सीक्वेंस. ओके निष्ठा, dense layer only this activation thing is necessary. Okay, but after that also we have another dense layer, so it's on to you. Means if you want you can remove this dense layer, it's not a problem. But here we are trying 2 dense layers. We can try even multiple dense layers also. उतना ही मेरा और मॉडल के वेट्स एडजस्ट होंगे और एक्यूरेट होने के चांसेस हैं. बट जब ये 1 घंटे में चला था होगा फिर 2 घंटे में चलेगा. ओके, तो अभी तक आपको ये क्लियर है कि भाई आपने LSTM लेयर क्यों यूज की, क्योंकि हमें सीक्वेंस प्रिजर्व करना है. तो शुरुआत में ही हमें सीक्वेंस लर्न करना है. एक बार वो सीक्वेंस बेस्ड प्रिडिक्शंस हो गई, उसके बाद बस हमें डेंस लेयर यूज करके फाइनल आउटपुट जनरेट करना है. अब बात ये आती है कि ये जो फाइनल डेंस लेयर है, यहां पर ये वोकैबुलरी साइज का क्या मतलब है? कैन एनीवन टेल मी वोकैबुलरी साइज का क्या मतलब है? लास्ट लेयर में इसके अंदर जो न्यूरॉन्स है लास्ट लेयर में वो वोकैबुलरी साइज के इक्वल क्यों है? लास्ट लेयर क्या प्रेडिक्ट करने वाली है यहाँ पे? लास्ट लेयर में आउटपुट न्यूरॉन्स होंगे, लेकिन हमारी वोकैबुलरी में डिस्टिंक्ट वर्ड्स कितने थे? 2600. दैट मींस 2600 न्यूरॉन्स इन दी dense layer, which is ultimately your output layer. In Keras, the last layer is the output layer, right? So that means for each word we will predict a probability that what is the probability that given a word this is the next word, and the word which has the maximum probability will be the output. Getting it, guys? Is it clear? This output layer is having vocabulary size, means we have to predict for each word we have to predict the probability, because I told you, right, कि कुछ words के combinations multiple बार आ सकते हैं, like hello Rahul, hello how are you, hello what is happening. तो hello with what, hello with hi. तो now सबकी probabilities हैं, लेकिन किसकी सबसे ज्यादा है? That is what we need. So that's what the vocabulary size is saying in the output layer. And softmax, because it can be sigmoid also, because we need now a probability. So we cannot have a ReLU here. Like here intermediate you had a ReLU, but here we cannot have a ReLU. We can have a sigmoid, we can have a softmax. Right guys, getting it? Why we have softmax here and why we have ReLU here? मतलब यहाँ पर आप कुछ भी रख सकते हो, बट मेन है कि आउटपुट आपको क्या चाहिए, प्रोबेबिलिटी. तो एक तरह से ये क्लासिफिकेशन प्रॉब्लम की तरह है इन सम सेंस ऑफ और अनदर. ओके, एंड वी नो दिस रिटर्न सीक्वेंसेस ट्रू क्यों है. अगर आप ये लेयर हटा दो बीच में से तो आपको ये रिटर्न सीक्वेंसेस को फॉल्स करना पड़ेगा. मतलब बाय डिफॉल्ट वो फॉल्स होता है. अगर आप ये वाली लेयर हटा दो बीच में से और सीधा डेंस लेयर में डालो, आप वो कर सकते हो. ये छोटी सी चीजें हैं, याद रखना. आपको एम्बेडिंग लेयर मैंडेटरी है, पहली लेयर LSTM भी मैंडेटरी है, ये ऑप्शनल है, इसको हटा सकते हो, बट अगर ये हटाओगे तो ये आपको फॉल्स करना पड़ेगा। ये भी ऑप्शनल है, इसको हटा सकते हो, लेकिन ये मैंडेटरी है क्योंकि आउटपुट है। यहां पर रेलू नहीं रख सकते, यहां पर सॉफ्टमैक्स या सिग्मॉइड ही रखना पड़ेगा। ओके, इतनी चीजें क्लियर है हमें गाइस? मोर पीपल कैन पिंग मी। सो फार यू आर विद मी? परफेक्ट परफेक्ट। अब बात आती है कि भाई ये एम्बेडिंग लेयर थोड़ा इंटरेस्टिंग सी चीज है, यहाँ पे ये क्या है? तो अभी मैंने आपको ऊपर एक चीज बताई कि ये जो इनपुट स्पेस मैंने क्रिएट किया अभी, ये जो एक्स और वाई मैंने बनाया, इसे मुझे वेक्टर्स में कन्वर्ट करना है, मतलब 0 1 0 1 0 1 में। सो embedding layer actually do this automatically for me. Understand it? Embedding layer do this automatically for you. There are some other things also which I'll tell you, but yeah. So yeah, so embedding layer will do what? It will convert that input space into a vector space, which is quite important. Give me a second. Let me show you it through a diagram. Okay, I'm just trying to search for a simple explanation. Okay, we will come to that. So that means for this particular data, we really don't need to worry much because embedding layer is going to take care of it. How, I'll tell you. But now this thing, the output layer, the actual output, I need to convert that on my own because मॉडल को मैं सिर्फ इनपुट भेजता हूँ, आउटपुट नहीं भेजता। इनपुट पे मॉडल ट्रेन होगा, बट आउटपुट is something which is my responsibility. So if you look at this, for example, if these are your layers, if these are your layers, you always pass input, right? You pass the input to the model and let model learn the things or predict something. So model when learn this, it predicts something. So say for example, the input that you are passing, you are still passing that 7 3 something like that, and embedding layer is converting it into a feature space. But finally the prediction that you are getting, guys, is again a vector space, which is something like 0 1 0 1 0 1. And now जो मॉडल प्रेडिक्ट करता है उसको आपको एक्चुअल चीज से कंपेयर करना पड़ता है, राइट? तो अगर मॉडल मेरा एक वेक्टर की फॉर्म में आउटपुट दे रहा है, तो जिस चीज से उसे कंपेयर करना है वो भी वेक्टर की फॉर्म में होनी चाहिए। तो दैट मीन्स जो मेरा y वेरिएबल है उसको मुझे एक वेक्टर स्पेस में कन्वर्ट करना है। ओके, आई एम जस्ट ट्राइंग टू एनालाइज इट इन अ सिंपलर वे। यू आर विद मी सो फार? दैट the input that I am passing, the embedding layer will convert it into a vector space and then generate a vector form output. तो मुझे यहाँ टेंशन लेने की जरूरत नहीं है, but because वो output will be compared to my output, then 0101 cannot be compared with this thing, with this thing, right? So now my responsibility is to convert this into that 0101 format, which is, you can say, a feature space, kind of a vector space kind of a thing. Sorry, vector space 0101. So for that, we have in Keras, there is a utility which is known as toCategorical, which is like one hot encoding, where you pass on your y variable and the number of classes in which you want that data to be represented. For example, in general, if you say that there is a word, hello, there is a word like hello Mike. Okay, so there is a word hello Mike, that's the person. So number of classes that can be generated, like if you talk about one hot encoding, so number of classes is like vocabulary size. So total words we have, distinct word is 2617. So total now columns that I can have is 2617 columns here. But now for this particular hello Mike, right, sentence, if I talk about putting these sentences here, so hello Mike, maybe this is hello, so it will be 1, and say if this word is Mike, this will be 1, the rest everything will be 0, right? Everything will be 0. So it's like you are creating a one hot encoding space. Now यहाँ तो मैंने 2 वर्ड्स की बात की, बट इन जनरल मेरे पास एक ही वर्ड होगा, तो इस पूरे में सिर्फ एक जगह पे 1 होगा, बाकी सब जगह 0, फिर इसमें बाकी सब जगह 0, लेकिन किसी एक में 1. Getting it? So let me show you this. So if you look at here, let's consider that these were your words, guys. 0, 1, 2, 3. They were like your words, and the number of classes you have 4. Understand it? The number of classes you can have 4. So number of classes consider is like number of words in your vocabulary. So you can have a word like 1, 2, 3, 4. Any one of these words it can be. Okay. Now 0 was, say, this word. So here you have 1, but for others it's 0. Okay, let's make it easy. It's A, it's B, it's C, and it's D. Okay. Number of classes can be 4, means you can have a word as A, B, C, or D. So for the first word, which is A, second is B, third is C, and then you have D. ये क्या है? ये तो आपकी vocabulary है, और ये क्या है? आपके actual words जो आ रहे हैं पीछे से. A matched with A, it's 1. B will be here 1, but rest it will be 0, like this. So guys, is it clear how this vector space is getting created, or a matrix is getting created before? Yeah, Karan, it will work because you have less data. मेरे लिए वो चलता रहेगा 2 घंटे तक, और मेमोरी भी फट जाएगा मेरे लिए वो. तो दैट मीन्स कि टारगेट को मुझे एक वेक्टर स्पेस में कन्वर्ट करना है, तो मेरा जो आउटपुट जनरेट होगा वो इस तरह से जनरेट होगा. ठीक है, तो ये हो गया मेरा टू कैटेगोरिकल. लेकिन इनपुट को मुझे इस तरह से कन्वर्ट नहीं करना, क्योंकि इनपुट मेरा एम्बेडिंग लेयर हैंडल कर लेगी. तो लेट्स गो बैक टू दिस. एम्बेडिंग लेयर भी क्या करेगी? ये वाला ही काम करेगी जो यहां आपको दिख रहा है ना. एम्बेडिंग लेयर भी वही काम करने वाली है. लेकिन हम टारगेट के लिए ये क्यों कर रहे हैं? क्योंकि टारगेट हमें पता है कि हमें 1 वर्ड प्रेडिक्ट करना है, तो ये कर रहे हैं. लेकिन इनपुट मैंने आपको बोला था कैन बी n ग्राम्स, यूनिग्राम्स, बायग्राम्स, ट्राईग्राम्स। तो हम 2 कैटेगोरिकल में इनपुट को भी कर सकते थे और एम्बेडिंग लेयर को हटा सकते थे, बट प्रॉब्लम ये है कि वो तभी सिर्फ सही होता जब हमारे पास यूनिग्राम होता। लेकिन बायग्राम ट्राईग्राम के केस में हम ये 2 कैटेगोरिकल अगर खुद करने बैठेंगे, इट विल बी वेरी वेरी कॉम्प्लिकेटेड, दिस विल बी अ वेरी बिग मैट्रिक्स। गाइस अंडरस्टैंडिंग इट? ये हम सिर्फ टारगेट के लिए क्यों कर रहे हैं, क्योंकि वो हमें पता है कि 1 वर्ड प्रेडिक्ट करना है। लेकिन इनपुट के लिए हम ये कर सकते थे अगर यूनिग्राम होता, लेकिन हम कल को उसको बायग्राम या ट्राईग्राम करेंगे तो हमें वो प्रॉब्लम ना हो, इसलिए एम्बेडिंग लेयर हमें दी गई है। एम्बेडिंग लेयर ये सब काम ऑटोमेटिकली कर लेती है, हमें उसे बस बताना होता है कि भाई तुझे यूनिग्राम, बायग्राम, ट्राईग्राम जो भी हैंडल करना है वो हैंडल कर लेती है। तो लेट्स गो बैक। तो अब यहाँ पर मैं जब इसे चला रहा हूँ तो ये चल रहा था थोड़ी देर पहले, लेकिन अभी ये पीछे एक तो मेरी कुछ प्रोसेस हैंग स्टेट में पड़ी है, तो वो कुछ मेमोरी खा रही है, मतलब ये मॉडल कुछ मेमोरी खा रहा है, और भी कुछ ऑब्जेक्ट्स बन चुके हैं मेरे सिस्टम की मेमोरी में, इसलिए मुझे मेमोरी एरर आ रहा है। मोर ओवर ये इतना बड़ा कुछ मैट्रिक्स बन गया है कि उसको 99 GB का मेमोरी मांग रहा है मुझसे। तो मेरे सिस्टम पे अभी ये चल चुका है तो मुझे कोई प्रॉब्लम नहीं है, लेकिन आप लोग इसको रन कर लो। आई एम पिंगिंग यू, just do this, it will work for you guys. Vocabulary size, so if you see हमने कैटेगोरिकल कन्वर्जन किया अपने टारगेट का from the feature space into the vector space, which is a matrix. तो जो मैट्रिक्स हमारा बनेगा उसमें कॉलम्स होंगे 2 6 1 6 and rows will be the number of records in the y. We will get that many total shape of the categorical this output, which is my target. So guys, so far if you are done, let's go into the embedding layer. So now I am saying that embedding layer is going to take care of, yeah Gulzar, you tell me. ये सब कुछ मैंडेटरी है गुलजार, मतलब what all is mandatory is the embedding layer, at least the the LSTM layer, and then the final layer. These intermediate layers are optional. The ones which I have highlighted, these are optional. But if you remove this wala layer, you have to convert this to false. Okay? Because dense layers. हाँ बोलो।
रिमूव कौन सा करने को कहा अभी आपने उस वक्त? स्क्रीन
ये दोनों लेयर आप हटा सकते हैं।
ठीक है सर,
ठीक है। और
ठीक है,
लेकिन फिर आपको इसको फॉल्स करना पड़ेगा, क्योंकि नेक्स्ट लेयर एक सीक्वेंस लेयर नहीं है, एक नॉर्मल लेयर हो जाती है अगर, तो आपको सीक्वेंसेस को फॉल्स करना पड़ेगा। ओके ओके, सो लेट्स मूव अहेड. We will talk about embedding, but we know the reason behind embedding. We will talk about these things. Okay, but let's move ahead. So I have created my layer. This is done. Then I am looking at the model summary. I'll come to embedding layer. I don't want to confuse you guys. Just let's go ahead. I'll come back to embedding layer. Okay, Aditi. Just remember what I have told, the important things, the important points, why we are using embedding layer, what embedding layer is doing, we know that, but how it is working, we will talk about that. What are these 3 parameters? We will talk about that. Let's come ahead. So now what you see is the embedding layer is actually a layer. That's why we are seeing it here, right? Embedding layer is actually a layer. So it's here. Then we have LSTM layer with 1000 neurons. The another LSTM layer with 1000 neurons, this dense layer, then this layer, Okay, and at each layer there are certain number of parameters which are being trained or adjusted. We will talk about this, but if you look at, there are too many parameters. Okay, so total parameters is around 15 million if you look at, which is really too much. Okay, so let's move ahead. Okay, so then we are coming to this, which is the important thing. We compile the model, right? We compile the model, we say the loss function, because it's somewhat like classification, it's cross entropy. But why it's not binary cross entropy? Can anyone tell me why it's categorical cross entropy? Why not binary cross entropy? Yeah, Karan, absolutely correct. It's multi-class classification. Yeah, Aditi, we are doing multi-class classification, means for any given word, the next word can be any word out of those 2617 words. For any given word, the next word can be any word out of those 2617 words. We need to calculate the probability for each of that word from the dictionary. Clear, guys? So that's why it's categorical cross entropy, not binary cross entropy. Okay. And then we have Adam optimizer and learning rate of 0.001 that we have set up. You can adjust these values. You can play with this changes to stochastic gradient descent or maybe to LBFGS. These are different things, but yeah, this is the loss function which we have to optimize using this approach. Now, finally, I'll come to this, which is I'm saying, oh, fit my model. This is your X, which is input, but it's not in the form of vector because we have an embedding layer. लेकिन अगर embedding layer नहीं होती तो ये vector form में देना mandatory है. Output here is in the vector form, 2 categorical. Okay, epochs 150, batch size 64. तो मतलब within each epoch there will be multiple iterations. Some callbacks, you can ignore this for the time being, not that important. Callbacks is ultimately we give if we have to call some functions separately, but this is not needed. This is to call some additional functions if I have created at the top. So there are some functions here, the checkpoint function, the reduce function, which we are calling separately, and tensor board visualization, which is to see this kind of visualization. But yeah, these are not needed. Let's remove this. You can remove it and you can just do this much. That's also fine. Okay, so you will fit this model and your model will be trained. Once this model is trained, we don't even need this. So once this model is trained, we will start it for prediction. So let's go one by one. Guys, have you run Gulzar? 0.01, 0.03 are the good values. 0.01, 0.03. Okay, Gulzar, 0.01, 0.03 are good values. Guys, I hope you have done till this. You won't get this memory error. Okay. Number of classes is my vocabulary size. After that, you have to create this, which is your model. We will talk about embedding, but it will take some time. Okay, but we know the purpose of embedding. You don't need to change anything here. We are using one word for learning, so it's 1. I'll tell you vocabulary size, and this 10 I'll tell you. But once you have created the model, you can check for the summary. Okay, we will talk about these parameters, but let's run it first. Okay, then you can simply do this, compile the model, and let me know if compilation tak ho gaya hai sabka, to just ping me yes or no. Okay, Pragesha? Perfect. This, run your neural network. And you can reduce the number of epochs to 5 or 6. Otherwise it will take time, but आपका डेटा कम है तो शायद आप लोगों के लिए जल्दी हो जाएगा. बट अभी के लिए नंबर ऑफ epochs चाहे तो 10 कर दो, वो 5-6 मिनट में हो जाएगा. ये एडिशनल पैरामीटर्स भी हम पास कर सकते हैं, but it's fine, which we did last time also. Guys, please let me know if your model is learning these kind of epochs. It must be doing, and giving you the value of the loss function at each and every interval, the loss function value. Okay, perfect, very good. No problem, let it learn, but now you will see that it takes time really to learn. While it's learning, it will be going through this reduction of the loss function. Your model will be actually converging to some point. We can plot this diagram, which is another thing, but yeah, you can use TensorBoard website to do that. But yeah, this is what your model is actually currently learning, and once it's done, it's completed with the learning phase. Now comes the prediction phase. Okay, so let's go to the prediction phase. So I'll tell you, okay, these things, don't worry about it, but this needs some dedicated time. An embedding layer which is going to convert your input data into some form of vector for the model. Okay, so now once we have our model, NLP model ready, we simply need to start the predictions. Okay. So what we have to do now is we will run this particular prediction function that is going to predict it. But let me explain you before going into detail of that. Is when I'll run this, okay, a particular word or a line, okay, it will ask me like type in something and just press enter, and it will predict the next word for me. For example, hello. It didn't found anything. Let me do collection. So this notebook, yeah, it predicted the next word for me. I'll tell you how I'm doing this, but before that, I'm giving you a demo. That our model is trained, it's good enough. Now I'm doing the predictions. So it's asking me to put in any word, and it will tell me the next word that this model might have learned. So for example, I ran this model initially for some 10 epochs, and this model was not learning good. तो ये मैंने आप लोगों को समझाने के लिए लिया है यहाँ पे. When I trained it in very less epochs, I passed on this particular word. It predicted me the next word is the after dull. But when I did it for hundreds of epochs, the next word it says weather. It's like dull weather. When you put the word dull, it says weather, dull weather. When I say textile, it says samples. If you look here, I actually tried with trigrams. Okay, I changed it to trigrams, but currently this model which I built in front of you is a unigram. So that's why I'm not putting 3 words, I'm putting 1 word and getting 1 word as output. If you put 3 words, again, you will get 1 word as output, but all these depends on how much model is trained. So initially when I was doing not enough training, see, it's giving me the, because it's not trained, क्योंकि अभी ये चल रहा है, शायद ये किसी hang state में जा चुका है. But if you run it again and again, you will see that it's learning. Let me check this word textile. It's saying confidence. Okay, so let me go back to the original document and see here. So if you look at textile, samples is something that is the next word which it should predict. And when I see here, it's saying confidence. But when I actually trained it over multiple epochs, it's giving me samples, right? And dull should give me weather. Let me go back and see how it's learning this. Is it really learning the pattern? So dull is weather also. If you see, pain is also there. Dully you can remove it through stamming and lemmatization to dull, which is the root word. Okay, but if you see, the probability could have been pain and weather, but it give me say pain or weather depending कि मैंने उसे कितना ट्रेन किया है. बट मेरे केस में मॉडल अभी इतना अच्छा ट्रेन नहीं हुआ. Even it is giving me the, it's predicting me next word as the. So let me take any word from here. This person, right, Grigor. So let's put this person's name Grigor here. So Grigor is saying now, but it should have actually say Samza. So again, let's go back and see. Grigor was having next words as Sansa, then, had, not, did, was, had, Grigor. Okay. So this model have learned some pattern, but again, it's not that good. Okay, but it's all about this person Grigor. So the point what I want to tell you is you need to train your model more. I trained it for 10 epochs and it's not good, but when I trained it for multiple epochs, it was good. Plus when I moved it from unigram to trigram, it was better. Okay, now what I'm doing here, we will continue tomorrow also, but what I'm doing here, let's see. I'm passing in some input, right? I'm passing in some input here, but now model is doing prediction. So let me take it out. But this input needs to be in the form of numerical vectors. So that I need to do. Okay, that's responsibility is on me. Means if you look here, okay, so just see here, what I'm saying is इनपुट डेटा जो मॉडल को पास होगा वो प्रिडिक्शन के टाइम पे उस फॉर्म में होना चाहिए जिस फॉर्म में आपने ट्रेनिंग डेटा भेजा था. ट्रेनिंग डेटा वाज इन दिस फॉर्म, राइट? ट्रेनिंग डेटा वाज इन दिस फॉर्म. सो that means you cannot pass a word directly. You need to convert it into this form, like a number 17, 53, 293, like that, right? So that's why whichever word you will enter, okay, whichever word you will enter, that word will, or that sentence will be split it first, and then I'm running a tokenizer on top of it. Okay, this tokenizer is actually having that logic which was done earlier here, which was done here. Yeah, so here you see this tokenizer, right? So this tokenizer logic will be implemented there. Okay, this tokenizer logic will be implemented there. But the point is, here the tokenizer, when I built the tokenizer, I built in, or consider this tokenizer as a model जो कि किसी एक वर्ड के लिए एक नंबर जनरेट करता है. लाइक हाई के लिए उसने एक नंबर जनरेट किया, हेलो के लिए उसने एक नंबर जनरेट किया. प्रिडिक्शन करूंगा हाई के लिए, तो हाई के लिए जो नंबर जनरेट होना चाहिए वो वही होना चाहिए जो ट्रेनिंग के टाइम पे हुआ था. तो प्रिडिक्शन करने से पहले जो मैं अपना डेटा कन्वर्ट करूंगा प्रॉपर फॉर्म में, वो उसी, ये हाई उसी नंबर से मैप होना चाहिए जिससे कि वो पहले हुआ था. लेकिन वो नंबरिंग अगर मैं नया टोकनाइजर लिखूंगा तो लॉस्ट हो जाएगी. हाई को नए नंबर्स मिलेंगे जिसकी वजह से मेरा सारा प्रिडिक्शन खराब हो जाएगा. दैट मीन्स द टोकनाइजर विच आई बिल्ट हियर, I need to somehow save its state so that when I call it in future, that same tokenizer will be called. So for example, if I am calling this tokenizer on high and value is 3, and now after 10 days if I again call this on high, the value should be 3. It should not change, right? Otherwise तो सब कुछ गड़बड़ हो जाएगा. That's why this tokenizer which was trained on my training data was saved in a pickle file, a output file. I said pickle.dump. Pickle is a package. I'll say dump this model into this file. This WB means write binary. Write in this file in the binary form. Now, since this model is written in tokenizer.pickle file, so when I will do prediction tomorrow using another notebook, this is another notebook, I will not write the tokenizer from scratch. I will do what? See, this this pickle.load. So there are two functions, pickle.dump and pickle.load. Remember हमने शायद एक pickle file बनाई भी थी शुरू में. Pickle.load, and we will say load this file in this tokenizer, so that when this tokenizer is again called, you're calling all those sequencing and all, that concept is not lost. That numbering of the words is not lost. Otherwise, embedding layer will generate a completely new vector space. So that's why if you see, when I'm predicting, I'm passing the model and the tokenizer and the text. So this text will first go through the tokenizer, get converted into that tokenization form, and then it will be passed through that model. Since this is a new notebook, I also need to pass that model here. So let's see, at the top, I am loading this model. .h5 फाइल, बट ये कहां से आई? This model which I built, yeah. So in Keras there is this model checkpoint. checkpointing आप लोग समझते होंगे, checkpoint मतलब एक जगह पे एक चीज को रोक के उसकी स्टेट को सेव कर लेना, उसको हम checkpointing कहते हैं। तो मॉडल को हमने checkpoint कर दिया, मतलब जो उसकी स्टेट थी वो सेव कर ली। तो मतलब मॉडल checkpoint फंक्शन will generate this file and yeah, so this file will be generated, जो भी आपका करंट मॉडल चल रहा होगा उसको इस फाइल में उसके स्टेज को सेव कर दिया जाएगा। तो लेट मी पिंग यू दिस, आई एम पिंगिंग यू दिस कमांड, you don't need to worry about these two, I'll tell you one by one. So this is what is important, because this model you can share it to anyone in your team tomorrow and say that you can use this model, because अगर हर कोई इस मॉडल को ट्रेन करने बैठ गया तो घंटे लगा देगा, हमें एक बार ट्रेन करना है और उसकी स्टेट को सेव कर लेना है, इसके बाद सिर्फ प्रेडिक्शन के लिए यूज करना है। तो गाइस प्लीज डू दिस and then go back to where your notebooks are and see if you can see this h5 file there. Please ping me if h5 is generated on your system. आपका जो os.get current working directory आप निकाल के देख सकते हो और वहां पर आपकी h5 फाइल बन जाएगी। सो बिफोर वी स्टार्ट प्रिडिक्शन हमें ये दो फाइल जनरेट करनी है। पहले h5 जनरेट करो, फिर मैं पिकल फाइल बताता हूँ। Guys, please ping me if this h5, these are actually special files, .h5, जैसे .pmml files होती हैं, somewhat similar, not same. You can convert a model into a pmml file or a h5 file, and then you can execute this h5 file from different programming languages like pmml file. But pickle file is always Python specific. Guys, please ping me if this file is generated or not. I'm also pinging you. I'm also sending you this thing to dump the tokenizer. So you have to dump the tokenizer and the model. That's it. करण, मतलब ये प्रोग्राम चल गया आपका या प्रोग्राम ही फेल हो गया ये वाला? ठीक है, टोकनाइजर बन गया, बट मैं कह रहा हूँ कि ये वाला फाइल आपका मतलब ये कमांड रन हुआ या फेल हो गया था? तो आप पाथ गलत देख रहे होंगे, मतलब जहां पर टोकनाइजर फाइल बनी है पिकल फाइल वहीं पे ही ये फाइल नहीं मिल रही है आपको .h5. I'll look later, give me some time. Guys, please ping me more people if they are able to generate these two files. I would like people to please respond if it's running, failing, done. Okay, Gomini, thanks. Tokenizer is done. But no, what's the problem with H5 file? Like the program is running or it's failing? It may so happen that आपने अभी तक अपना मॉडल completely train कर लिया था, or look at the top if there is something which is still running. I'll look into it, no problem. For those it's not generating, but yeah, what we have done so far, I hope you guys are clear. So we have took the data, we cleaned it through multiple processes, and then finally built our model using the embedding layer, LSTM, and all the layers, trained the model, and then finally we have started the prediction. But for prediction, we needed two files, so we generated those two files, the pickle file and the H5 file. Pickle file is for the tokenizer, means any general Python logic you can put in the pickle file. Any model logic you can put it in PMML or H5. These are special extensions. Okay. So any generic Python processes, pickle file, but model related things in PMML or H5. Okay. So now I am going into the predictions thing. Here I am loading these two files in the tokenizer and the model. Then I am asking to predict, passing the model as is the trained model with the tokenizer, because we know why the tokenizer, and the text, right? Then whatever text we have, we will generate a sequence number for it. We will get a sequence number for it. Array of sequences. It can, if it's a one word, it is one sequence. And then for that particular sequence, I am just doing the prediction. Model.predict. So this is Kera's model.predict. Predict or predict classes. It will give me the output. The output class will be provided to me, but that will be a number. Okay, it will be like a number. But for number, what was the actual word? How will I get it? I have to go back to the tokenizer and say, boss, for this particular number, tell me the value. Let me go back here. So if you look at the tokenizer, earlier we were just saying tokenizer text through sequences, and then we were just taking this thing, right? Zeroth value, right? But now what I'm saying is, when you do tokenization, guys, each word is given a number. If you look here, each word is given a number. So tokenizer.wordindex.items, ये डिक्शनरी है एक आपके पास, जैसे आप डिक्शनरी बनाते हो, रन करके देख सकते हो, मैंने पिंग किया है, तो आप देख सकते हो कि हर एक वर्ड को एक नंबर मिला है 1 2 3 4, और वो कोई अल्फाबेटिकल ऑर्डर में नहीं है, वो उस ऑर्डर में है जिस ऑर्डर में वो वर्ड आपके डॉक्यूमेंट में मिला. ठीक है, आपके डॉक्यूमेंट में किस वर्ड में, ऐसा नहीं है कि जो चीजें ए से स्टार्ट हो रही थी वो पहले नंबर पे आएंगी, फिर बी वाली बाद में आएंगी, ऐसा कुछ नहीं है. इट ऑल डिपेंड्स ऑन द ऑर्डर इन योर ट्रेनिंग डॉक्यूमेंट. ओके, तो अब जब आपका मॉडल प्रिडिक्ट करेगा, क्योंकि मॉडल को आपने 1 2 3 तो पास किया था, तो मॉडल भी 1 2 3 ही देगा. आपको उस 1 2 3 वैल्यू को इस टोकन इस डिक्शनरी में लुकअप करके एक्चुअल वैल्यू रिटर्न करवानी पड़ेगी. तो अगर आप यहाँ देखेंगे तो यहाँ पर बस यही हो रहा है कि वैल्यू के लिए जो की है वो आप निकाल रहे हो, एंड दैट्स इट, वी आर डन. दैट्स व्हाट दिस होल प्रोसेस इज. You are right, word sequence is the right word in the paragraph. It's the word sequence in the paragraph or in the document. तो ये numbers आपके document के हिसाब से होते हैं. Guys, end to end process clear है आपको? कोई question है, कोई doubt है before we end the class for the day? I'll upload all these notebooks on the GitHub. Take it, run it. Any questions? So yeah, that's what. I'll upload this, read it, and then we will discuss this again tomorrow. I know this is what this thing is. मैं एक बार end to end process रिवाइज कर रहा हूँ, एक बार रिपीट करूंगा end to end process. उसी ऑर्डर में आपको इसको प्रैक्टिस करना है. फिर कल हम डिस्कस करेंगे. और कल हम क्या डिस्कस करेंगे? इट विल बिकम मोर कॉम्प्लेक्स. ये तो अभी पहला प्रोग्राम था जो आपने शायद किया है एनएलपी का. It will become more complex. Okay, but what I am saying is I'll explain you the end-to-end process and then do it. And tomorrow we will discuss about embedding layer in detail. वरना वो और confusing हो जाएगा. And what those parameters are, वो कैसे calculate हो रहे हैं इतने सारे parameters. We will talk about that tomorrow. Okay, these number of parameters and the embedding layer we will talk about tomorrow. But yeah, what you guys need to do, listen carefully. मैं यहाँ पे एक लैंग्वेज मॉडल इंप्लीमेंट कर रहा हूँ. लैंग्वेज मॉडल मतलब ऐसा मॉडल जो कि नेक्स्ट वर्ड को प्रेडिक्ट करता है. ओके, अब नेक्स्ट वर्ड प्रेडिक्ट करने के लिए मुझे डिसाइड करना है कि क्या मैं 1-to-1 मैपिंग चाहता हूँ या मल्टीपल टू 1, मतलब 1 word to 1 word और मल्टी वर्ड टू 1 word. ओके, दैट आई नीड टू डिसाइड. It's something like the RNN architectures, right? 1-to-1, many-to-1, many-to-many. Okay. So I implemented 1-to-1, as in for 1 word, 1 word. But now to train that model, what I need here is to clean the data. To clean the data means convert everything into lowercase, remove the punctuations, remove the new line characters, remove the stop words, bad words. Okay, and then tokenize it. But after tokenizing, I need to give a number, a sequence, because it's a sequence model, right? I need to give a number to each word. So I did that. But after that, I converted into feature and target form, because that's how model will fit, right? Fit करते समय train और मतलब x और y आपको पास करना पड़ता है, right? तो हमने उसको split किया इस फॉर्म में, लेकिन इस फॉर्म से फर्दर हमने उसको split किया 2 अलग अलग पार्ट्स में, x को अलग, y को अलग. लेकिन अब इसके बाद ये डिसीजन मुझे लेना है कि क्या मुझे यहाँ पे एम्बेडिंग करनी है, मतलब दिस इज नोन एज वर्ड एम्बेडिंग, या फिर मैं कह रहा हूँ मॉडल खुद से एम्बेडिंग करेगा मेरे लिए. तो मैं खुद से एम्बेडिंग ना करके मॉडल को बोल रहा हूँ कि भाई तू मेरे लिए एम्बेडिंग कर. अगर मॉडल आपके लिए एम्बेडिंग करेगा मतलब पहली लेयर आपकी एम्बेडिंग लेयर होनी चाहिए. बिल्कुल ठीक बात है. First layer of the model will be the embedding layer, which will convert these numbers into some vectors, and then it will do the prediction. So what I did, I built this model. I further trained it, like compiled it and trained it. But the important thing was, because my input is getting embedded, my output should also be in the embedded form. Who will do that? I need to do that using Keras two categorical function, which is like one hot encoding. Similar to that, not same. And that's it. My model will be ready for prediction. So tomorrow when I give a single word, my model will predict a word for me like this. If I pass on any word here, like Samza, it's saying I. I'm saying collection, it's saying rested. So for one word, it's giving me one word. But let's see if this is the model, this word is going inside the model. Output that is coming is this, right? But पीछे बहुत सारा magic है. क्या है? This word model does not understand. So you have to first do what? Tokenize it. So any future word that you want, इसके लिए prediction आपको करना है, जिसके लिए पहले उसको टोकनाइजर से आप पास करोगे और टोकनाइजर को बोलोगे भाई इसको नंबर की फॉर्म में कन्वर्ट कर दे. नंबर को एम्बेडिंग लेयर यहाँ पर मॉडल में लेगा और एम्बेडिंग लेयर उसको 0101 के वेक्टर में कन्वर्ट कर देगा और उसको लेयर्स के थ्रू पास करेगा. और फाइनल जो आउटपुट आएगा नेक्स्ट वर्ड, वो एक वेक्टर आएगा 0101 का. मॉडल उसको रिवर्स एम्बेड करेगा और एक तरह से नंबर में कन्वर्ट करेगा, मान लो 41 और समथिंग, जो कि उसका सीक्वेंस नंबर है वर्ड का. तो आपको मॉडल क्या रिटर्न करेगा? 41. ओके, बट उस 41 से एक्चुअल वर्ड आपको कैसे मिलेगा? टोकनाइजर के पास जाओगे कि भाई मेरे को ये वर्ड मिला है. टोकनाइजर कहेगा ठीक है, मेरे पास तो एक डिक्शनरी है, उसमें 41 के लिए जो वर्ड है वो मैं तुम्हें बता देता हूं. तो ये गाइस समझ रहे हो? आप एक वर्ड जब भेजोगे, पहले आपकी रिस्पॉन्सिबिलिटी है उसको टोकनाइज करना. जब ये इस फॉर्म में आ गया तो मॉडल उसको खुद एम्बेड करेगा, उसको प्रेडिक्ट करेगा जो भी प्रेडिक्ट करना है. लेकिन जो इनपुट फॉर्म मिली वही आउटपुट फॉर्म आपको देगा मॉडल. अगर आप मॉडल को वेक्टर देते तो वो आपको ये वेक्टर देता, लेकिन क्योंकि आपने मॉडल को क्या दिया है? एक नंबर, तो मॉडल आपको भी एक नंबर देगा. फिर लेकिन इस नंबर से वैल्यू निकालना आपकी रिस्पॉन्सिबिलिटी है, ये वाला काम मॉडल ये नहीं करके देगा. तो मॉडल टेक्स इन अ नंबर, गिव्स अ नंबर, which is like a index, tokenizer index. Model does not take a word or does not even give you a word. It takes an index, gives an index. But if you give a vector, it will return you a vector. Okay, that's the whole process. This is the model, but before that and after that you have to do tokenization, you have to do reverse tokenization, you have to do, as in look up in the tokens, which is this. अभी क्लियर है अदिति? कंफ्यूज? निष्ठा? guys, all of you? Okay, thanks Nitika. Guys, getting it end-to-end process? Aditi, Nishtha, still confused? It's fine, no problem. If you are still confused, please ping me at least. No, yes means it's clear, or you are still confused? Those who ping me privately, I'm asking those. Okay, Nishtha. Aditi, what about you? Aditi, Gomini, Harshita, Gulzar? Okay, Gomini, thanks. Harshita, if you guys are there, जिनका मैं नाम ले रहा हूँ. Okay, thanks. Rahul. Guys, I want each one of you to be equally aware about whatever we are doing. Pragisha, Tanya, Vipul. Okay. Okay. Thanks, guys. Okay. Me it is clear after my revision. Yeah. In final comparison of actual target versus preview actually gets compared vector or the token value. Okay, we'll come to that. Okay, guys. So before we close it, let me see few more things. So Aditi, tokenization and sequencing are different things. Tokenization just tokenizes the words, convert it into an array of words, a bag of words. But then you have to assign numbers to it. 1, 2, 3, 4. That is sequencing. Okay. Tokenizing is different. Sequencing is different. Okay. Read about it more. But yeah. What is the main purpose of the n-gram method? Whether unigram, bigram. So गुलजार ये तो सब आपके उस पे डिपेंड करता है बिजनेस प्रॉब्लम पे कि आपको यूनिग्राम बायोग्राम ट्राइग्राम क्या यूज करना है. मतलब ये आप पे है कि आप यूजर को रिकमेंडेशन जो दोगे नेक्स्ट वर्ड का वो आप कब देना चाहते हो. आप एक वर्ड टाइप करते दे देना चाहते हो या आप कहते हो मिनिमम 2 वर्ड टाइप करना चाहिए उसको. आप कहते हो नहीं मिनिमम 3 वर्ड टाइप करेगा तब मैं उसको दूंगा. क्योंकि आप खुद सोचो कि जब कोई मिनिमम 3 वर्ड टाइप करता है तो चौथा वर्ड प्रिडिक्ट करना आसान है. आसान से मेरा मतलब है एक्यूरेटली प्रिडिक्ट करना. आसान तो आप एक वर्ड के लिए एक वर्ड प्रिडिक्ट कर सकते हो लेकिन क्या आप एक्यूरेटली प्रिडिक्ट कर रहे हो. क्योंकि जितने ज्यादा आप वर्ड्स को कंटेक्स्ट में डालोगे उतना ज्यादा आपका कॉम्प्रिहेंशन अच्छा होगा कि आखिर ये बंदा चाहता क्या है. फॉर एग्जाम्पल अगर मैं यहां पर भी बात करूं लाइक अगर आपने ये टाइप किया सामजा वॉज अ ट्रेवलिंग then I can easily tell you salesman. Okay, so to predict this using the last 3 words, the next word is more accurate. Okay, but let me take some examples here itself. I'm just trying to look at a good example in this context. Quietly moving forwards, God in heaven. So यहाँ तो ऐसा कुछ अच्छा एग्जाम्पल नहीं है but let me consider when you write an email. Okay, let me tell you that. So when you write an email and you want to type like kindly do me a and then the next word is favor. Okay, so that means if you type kindly do me a then favor makes sense, but if you say kindly or do me then predicting the next word to be favor is not that accurate. So if you write kindly and I predict the next word as favor, that is not accurate. But you say kindly do me and then I'll say okay next word is favor, then it makes more sense. Okay, because if you write kindly, there can be multiple options of the words and it may not be in the context, so you will not use it. So that's what Gulzar, the point is. The more the words, the better the chances of predicting the next word. If you can learn the pattern, like longer history, like LSTM. Okay. Okay, guys. So please use this, and again, yeah, this notebook also. You can definitely use this notebook also. Okay. Stop this. ये अभी यहाँ पे देख रहे हो ना, ये रनिंग स्टेट में है, देख रहे हो रनिंग स्टेट में है, बंद हो गई नोटबुक का, फिर से चालू हो गई, वो कुछ और फंक्शन मैंने चलाया था, बट इट्स एंडिंग द प्रोग्राम, वो एंड हो रहा है। ऐसा क्यों है? बिकॉज मैं एक लूप में घुसा हुआ था, आई वॉज इन अ इनफाइनाइट लूप, और उस इनफाइनाइट लूप से बाहर मैं तभी आ सकता हूँ, मतलब ब्रेक मैं तभी कर सकता हूँ जब मैं एक पर्टिकुलर वर्ड टाइप करूँ, स्टॉप द स्क्रिप्ट। सो एनीवेज, दैट वाज जस्ट टू टेल यू, ये अभी स्टॉप हो गई है स्क्रिप्ट। मतलब आपका ये प्रोग्राम चलता ही रहेगा, ये तब तक बंद नहीं होगा अगर आप ये प्रेडिक्शन नोटबुक खोलेंगे, जब तक आप ये टाइप नहीं करोगे स्टॉप द स्क्रिप्ट। गाइस समझ रहे हो? क्योंकि तब तक मैं एक इनफाइनाइट लूप के अंदर हूं, और उस लूप से बाहर तभी निकल सकता हूं जब ये ब्रेक वर्ड हिट हो। ये ब्रेक वर्ड तब हिट होगा जब मैं ये टाइप करूंगा स्टॉप द स्क्रिप्ट उस फंक्शन के अंदर। मतलब ये खुल गया जैसे, अब मैं ये टाइप करता जा रहा हूँ, ये इन्फाइनाइटली मैं इसके अंदर फंसा हुआ हूँ, मैं इससे बाहर नहीं निकल सकता। मैं कह रहा हूँ ग्रिगोर, एंड इट्स गोइंग टू टेल मी द नेक्स्ट वर्ड। डेफिनेटली ग्रिगोर का ग्रिगोर ही दे रहा है ये अभी। हेलो का लेट्स सी, हेलो के लिए उसके पास कुछ प्रेडिक्शन ही नहीं है। So I'm telling you, like textile के लिए samples it's giving me, right? Next word, but I'm saying stop the script, so it's ending the program now and coming out. ठीक है, ये बाहर निकलने का तरीका है इसमें से। गाइस इज इट क्लियर जो भी मैंने बताया कि मैं लूप में से बाहर कैसे निकलूंगा, वरना ये नोटबुक चलती रहेगी। ठीक है, तो मैं ये दोनों नोटबुक और वो फाइल सब अपलोड कर दूंगा एक फोल्डर बना के अभी। प्लीज practice it, and tomorrow we will talk about embedding layer and the number of parameters which you were seeing, 15 million parameters. या गुलजार, एंडिंग मतलब आप इस नोटबुक से बाहर आ जाओगे। ये देख रहे हो ऊपर ये बुक बनी हुई है, मतलब आप अभी कुछ नहीं चल रहा लेकिन जब कोई नोटबुक चल रही होती है उसका मतलब क्या है, ये स्टार बना हुआ है यहाँ पे, और यहाँ ये आवर ग्लास बना हुआ है। ठीक है, इससे आप बाहर तभी आओगे जब आप वो एक मेन वर्ड लिखोगे जो आपने ऊपर स्क्रिप्ट में डाला हुआ है। तो आपका प्रोग्राम ये देखता है कि भाई आप वर्ड डालो, जैसे आप वर्ड डालोगे वो पहले देखेगा क्या वो वर्ड वो है स्टॉप करने का, अगर है तो ब्रेक कर दो, बाहर निकल जाओ, अगर नहीं है तो वो आपके मॉडल को कॉल कर रहा है प्रिडिक्शन के लिए। ठीक है, रियल वर्ल्ड में हमें इस तरह से काम करना होता है। ठीक है
सर, एक्चुअली अभी
बोलो बोलो।
सर एक्चुअली एंडिंग द प्रोग्राम का मतलब अब ये एंड हो चुका है जो लिखा रहा है एंडिंग द प्रोग्राम।
यस हाँ गाइस, थैंक यू, बाय बाय गाइस, बाय। हाँ ये प्रोग्राम एंड हो गया, अब आपको उसको दोबारा स्टार्ट करना पड़ेगा अगर फिर से कुछ प्रेडिक्शंस करने हैं तो। ठीक है, okay. Okay guys, we'll connect tomorrow, and Vipul, yeah, I'll answer your question tomorrow. Okay, we don't have much time now, so I'll answer that tomorrow. Okay guys, thank you. After half an hour you will get these notebooks on the GitHub.